Right. Good morning, ladies and gentlemen. My name's Nigel Cornwall of New Anglia Energy. I'm going to be your moderator for our programme this morning. We have already had through Foresight Hydrogen a couple of events in a themed programme, one on accelerating the hydrogen economy, another on innovation with supply and storage in hydrogen. Today, we're going to take our first look at demand side issues and usage issues. And the theme today is decarbonising industry and homes and some of the trade-offs and choices facing stakeholders. My involvement in hydrogen is relatively recent. We launched Hydrogen East a little over 2 months ago. And since then, there has been a huge level of interest and activity. And I think one of the very early conclusions that I came to was that we are not going to hit net zero without a material contribution from hydrogen. And I think that's a consensus view held within the industry, whether it is in terms of production, storage, and use in a range of economic sectors, obviously power, obviously in the gas system, which we're going to hear about today, but also in transport, agriculture, food processing. It is a key element of the debate. We have a full programme, 3 hours worth, and some super speakers. The programme will first start with Danielle Stewart from National Grid, who I will hand over to in a moment. We then have a panel session with 4 very well-known commentators and to look at what are the priorities that need to be set in the short term. We don't have a hydrogen strategy yet. Hopefully we'll have one early in the new year, but where should we be focusing and how can we be unlocking opportunities? As we go through the rest of the programme, I will introduce the speakers at the time, but rest assured we have a very diverse and good mix of themes and speakers. So I will kick off now by handing over to Danielle Stewart. Danielle is the Future Systems Manager at National Grid and is going to be talking to us about converting the gas networks for use of hydrogen. And each of the speakers has a slot of 20 to 25 minutes, leaving some time for your questions, which I would invite you to post on the backstage tab of your screen. So that's all I've got to say for now, and therefore over to you, Danielle. Thank you.
Thank you, Nigel. So good morning, everybody. I'm Danielle Stewart. I'm the long-term strategy manager for National Grid Gas Transmission. And I should say, for those of you expecting to see Tony Green this morning, he sends his apologies. He's had a short notice change of plans, so I stepped in, but hopefully I can do his slides justice. So as Nigel says, I want to talk to you this morning about converting the UK gas networks to hydrogen. And the introduction of a UK net zero emissions target by 2050 or 2045 if you live in Scotland provides a significant challenge to ensuring the resilience and the sustainability of the UK's energy system. But it also provides us with the opportunity to investigate and implement alternative decarbonised or low carbon sources of energy such as hydrogen. Now, to deliver against the net zero target, we're going to need a clearly defined and deliverable strategy to decarbonise the UK's gas sector, and one that also maintains the reliability and value for money that end consumers are going to expect. Now, innovation and collaboration across all sectors will be critical to success, and with ongoing meaningful stakeholder engagement key to creating a shared vision of that future. So natural gas has a central role to play in the UK's energy system today, It heats around 85% of UK homes, and it generates around 40% of our electricity. The UK's gas transmission system consists of around 7,500 kilometres of high-pressure pipelines. We have around 23 compressor stations, 8 gas terminals, including 3 LNG terminals, and we're interconnected to Europe. So we're connected to Belgium, the Netherlands, and Ireland. And to give you an idea of the scale of the decarbonisation challenge, the gas network transports almost 3 times as much energy per year on average when you compare that with electricity wise. And on a cold winter's day, it could be as much as 4 to 5 times the amount. So creating a more sustainable energy system is one of the greatest challenges that we face today. There have been several publications that consider the mosaic of solutions that we're going to need to decarbonise heat, power, transport and industry, as well as the pathways to achieving net zero. And as Nigel mentioned just now, many of these scenarios conclude that hydrogen is going to have to play a crucial role. Now, every year, National Grid's electricity system operator publishes its future energy scenarios. And this year, there's 4 scenarios with different credible pathways for the future of energy over the next 30 years. And 3 of these scenarios meet net zero. And that's consumer transformation, system transformation scenario, and leading the way. And all of these look at the level of societal change needed versus the speed of decarbonisation. And a key point to note is that hydrogen will play a key role in every one of these net zero scenarios, and they will provide between 21 to 59% of the 2050 net zero end user energy needs, according to these future energy scenarios. And there's several key messages that are highlighted in the report. And one of those key messages says that hydrogen and carbon capture and storage must be deployed for net zero. And we're going to need industrial scale demonstration projects to be operational in this decade. So it's quite a significant challenge. So I mentioned earlier that collaboration and innovation are going to be key to achieving net zero. And earlier this year, the Energy Networks Association and the UK Gas Networks together launched Gas Goes Green. And it's a comprehensive and collaborative programme to transform our networks to deliver green gas to consumers across the UK. So that's biogas and hydrogen. And that builds on the foundations of our existing grid infrastructure and innovation programmes. Now, as part of the programme, we proposed a number of key deliverables for this year. And we've already had some of those deliverables published. Just to give you some examples, we published our zero carbon commitment. So with 85% of Britain's homes connected to around 284,000 kilometres of gas pipelines around the country, this commitment sets out the network company's plans to invest around £904 million in projects across Britain's regions. And that's between 2021 and 2026, which is the timeline for the RIIO-2 regulatory price control. We've also had a number of webinars. We had a webinar looking at strengthening the case for the gas safety management regulations. And we also had a webinar looking at grid-scale trials of gas separation. And that was a hydrogen deblending workshop with around 85 individuals across the industry. And it was a 2-way interactive workshop where we learned an awful lot about what people thought of that particular process. We've got a number of upcoming deliverables through Gas Goes Green. We're planning in the autumn time to publish our hydrogen transformation plan. And this is a vision for how networks and the wider activity is building the evidence base for the role that hydrogen can play across the energy system. We are also looking at the future of gas in transport. So it's a collaborative innovation project with all the gas networks. And we're working with Element Energy to look at the pathways for gas to support decarbonisation of transport. We've recently just published an interim report on that. So a number of things happening, and if you want to find out more on this, please visit the Energy Networks Association website. A lot of collaborative work happening already in the industry. But really I want to focus on some of the work that National Grid Gas Transmission is doing to look at hydrogen. The first item I want to look at is around asset readiness. So we're beginning to determine how ready our assets are for hydrogen. And we put out a first data request to our suppliers to understand the compatibility of the assets on the gas national transmission system with hydrogen. And early results indicate a high degree of readiness. Now, the chart on the right is very similar to a version that Melco Gas completed, which combines knowledge across all platforms. And we've taken a similar approach for National Grid and pulled knowledge from the first supplier data sets. So largely the findings are in keeping with findings across Europe. On the vertical axis of this chart, we're showing increasing volumes of hydrogen blended with natural gas. And on the horizontal axis are different types of assets. And the colours shown is a basic RAG display. So green is good, red is not so good. The dark green shows assets where we see no significant issues based on the available studies to date. Light green is where we expect some modifications may be needed. And amber shows that it's technically feasible, but there might be significant modifications needed. The red hatchings are where further investigations are planned, and the solid red is where it's not technically feasible at the moment. So that solid red line at the moment is showing heat exchangers, and they're not compatible with hydrogen, we believe, but we do need to understand whether heat exchangers will be required in hydrogen network in the future. The Joule-Thomson effect for hydrogen is slightly different for natural gas. So it's early days for this work. And our next steps will be to carry out another round of supplier surveys, and we're going to supplement it with our own data and data from elsewhere so that we can develop a full asset risk model for hydrogen conversion. We've also been looking at hydrogen NTS modelling. We've carried out some high-level modelling of the national transmission system to look at its capacity for transporting hydrogen in 2050. Early results indicate that the existing infrastructure capacity should be sufficient for transporting the required volumes in 2050. The modelling hasn't yet looked at any infrastructure implications throughout the transition from natural gas to hydrogen. And there are a couple of limitations at the moment. It is very early days, and this was a high-level piece. We know we're going to need to update our assumptions as more information becomes available, but a couple of things to pull out. The model currently assumes that hydrogen is produced at current entry points and that hydrogen demand is located in the same places as it is today. And we know this is unlikely to be true in the future. And currently the models also use the 2019 future energy scenarios for supply and demand as a basis. This will absolutely need to be updated using the latest FES scenarios that I mentioned previously. So early days, but an encouraging result given the limited data set that we have, and we are planning to do a lot more work in this space going forward over the coming months. So over the next few slides, I want to introduce you to our HyNTS or HyNTS Future Grid programme. And HyNTS is the banner capturing all of National Grid Gas Transmission's hydrogen innovation projects. And Future Grid is one of our most significant pieces within the portfolio. So we're currently in the process of submitting a £10 million network innovation competition bid, and I'll go into a little bit more detail about what that means over the next couple of slides. Now, I've mentioned collaboration a few times now, and we know it's going to be key to develop our own hydrogen capabilities, but we're going to need to learn from others and share knowledge if we're going to transition to a net zero future in an effective and efficient way. Now, on the left-hand side of this slide, I've mentioned some of the stats already, but I do want to highlight some of the areas where we're already working together with other industry experts to help us develop the net zero pathway for the gas national transmission system. So there's a number of hydrogen projects already happening and programmed. A lot of them are being led by the gas distribution networks, and these include NGN's H21 project, looking at the impact of hydrogen on repurposed distribution assets. There's Cadent's HyNet project in the northwest. The HyDeploy project at Keele University is already transporting close to around 20% blend of hydrogen with natural gas to over 100 consumers on their campus. There's the Wales and West HyHy project and SGN's H100 project, looking at the impact of new hydrogen on new pipelines. And all of these projects are complementary, and the networks are working together to share their learning. I've also mentioned Gas Goes Green just now, but I also wanted to pull out the fact that we're collaborating through the Hydrogen Programme Development Group. And this is a fully coordinated and appropriately governed joint government and industry programme. We know that hydrogen is one potential key option for decarbonising heating, alongside other solutions such as heat pumps and heat networks. But we're working together with the Department for Business, Energy and Industrial Strategy, as well as wider industry, to build a collaborative and comprehensive programme of work to provide the necessary evidence base for hydrogen in networks. And this will look at safety, feasibility, costs and benefits, and the overall consumer experience. And as our knowledge and evidence base develops, we expect the outputs of this programme will help to inform future policy on heat. We're also working with other European transmission system operators, such as SNAM and Gasunie, to share knowledge and learning from their hydrogen demonstration projects. And as I mentioned just now, we have National Grid's HyNTS programme, which to date has provided desktop evidence of the NTS capability and capacity for hydrogen. So all of this builds a collaborative pathway to a net zero future. So what's Future Grid? So Future Grid is an ambitious and innovative, as well as collaborative programme that seeks to build a hydrogen test facility from decommissioned transmission assets. And this will allow us to test the impact of hydrogen on our assets from a safety and materials and operational perspective. And if it's successful, it will enable us to demonstrate the ability of the NTS, or National Transmission System, to transport hydrogen. So there's several phases to the programme, with early work already started on the planning and scoping of the trials that are going to be needed. This is through a Network Innovation Allowance funded project. So that's a regulatory mechanism for innovation projects that we use. Its aim is to set out the defining the principles, the specification and pipeline configuration needed for the test facility. And it's to allow for timely building and testing of the facility going forward. So we're currently looking to start phase 1 of the programme early in 2021, when we'll start to build the offline test facility, should we be successful in securing necessary allowances. We're hoping to secure allowances through the Network Innovation Competition process. So the Gas Network Innovation Competition is an annual opportunity for gas network companies to compete for funding under the regulatory framework. And funding is awarded for the best innovation projects that help all network operators understand what they need to do to provide environmental benefits, reduce costs, and maintain security of supply as Great Britain moves to a low carbon economy. There's up to £20 million per year available through the Gas NIC. And it's through this process that we hope to secure around £10 million to be able to complete the first phase of Future Grid. We've submitted plans to Ofgem in July, and construction of this facility in 2021, with testing beginning in 2022. So phase 2 includes plans to validate deblending technologies to separate hydrogen from natural gas and demonstrate its impact on operating compressors. And this is to enable a flexible transition to hydrogen. And phase 3 looks to enable third-party collaboration and testing, and that's to carry out trials on a live NTS.
You encountered our issue early on, and you were in full flow, and I was writing copious notes, and would love you to carry on.
Thank you.
Over to you.
Thank you. I'll try to share my screen. Technology has been wonderful over this period, hasn't it? But you do need to be prepared for some of these little blips.
Yeah, absolutely. The new normal.
It is. I'm not sure where I got to, because I carried on speaking for quite some time after I realised I'd lost connection with you. I don't suppose you remember where I got to, and I'll pick up from there.
You were talking about the future project, and you were halfway through your timeline, I think. You did the asset readiness stuff, the modelling work you're doing, and I think we were just on to the next slide.
Perfect. This slide?
Yes, yeah, I think you were at the back end of that, yeah. Excellent.
So if I was at the back end, I will just quickly review this slide and then move on. Thank you very much, Nigel. Thank you. So I've explained what Future Grid is, and for those of you who may have missed it, I will just pick up again. It's an ambitious facility from decommissioned transmission assets. And this is really to allow us to test the impact of hydrogen on transmission assets from a safety, materials and operational perspective. So if it's successful, it will enable us to demonstrate the ability of the National Transmission System to transport hydrogen. So earlier on, I believe I outlined this phased programme. We're currently looking at the NIA, so the Network Innovation Allowance phase at the moment. That's allowing us to scope the future work with a view to start this Future Grid programme phase 1 in 2021. I mentioned earlier on the Network Innovation Competition process. So we're currently going through that process, applying for funding. We've submitted our proposals to Ofgem in July, and hopefully we will hear in November the outcomes of that proposal. We're hoping to start build of the test rig in early 2021 with a view to start testing a range of blends of hydrogen on those assets by 2022. Phase 2 will look at deblending test facility. So it's plans to validate deblending technologies in order to separate hydrogen from natural gas. We also propose to look at compressors and the impact on operating hydrogen with them. And all of this is to enable a flexible system transition to hydrogen. And finally, phase 3 looks to enable third-party collaboration on this test rig so that they can carry out trials so that we can carry out trials on the live national transmission system. Now, it's worth noting that phase 3 doesn't have to wait for phase 2. We would need to find an appropriate part of the network to introduce hydrogen to and a willing customer to work with, but we have captured that now because previously we were talking about offline testing only. So if I move on from here. So as I said, we're looking to build a hydrogen test facility from decommissioned transmission assets, and this is at DNVGL Spade Adams site in Cumbria in the north of the country. So we plan to connect our test rig to NGN's H21 distribution rig, and that's to create a representative UK beach to burner network. There'll be a high pressure reservoir where hydrogen will be tankered in, and this will then feed into a national transmission system equivalent entry point before flowing through the transmission assets and into the distribution assets via a typical exit point. So one of the longer term benefits of this setup is that it can be used in the future as a training facility to upskill our engineers, and it can train the engineers of the future too. We also propose to open the facility for third-party testing, and that's to allow for new technology trials and manufacturer-led impact assessments, and that's to accelerate the supply chain transition to hydrogen. So phase 1 of the programme is split into 3 parts. On this slide, I want to talk about phase 1A, and it's all about building the test rig from decommissioned assets, and it's planning to take a modular approach so that facility can be flexed in size as the projects mature. We believe there's the potential to save around £5 million by using repurposed assets, and the assets will be sourced from all over the network in different parts of the country to really ensure that it's truly representative of the assets on our system. And we plan to test everything from flow control valves to flow meters, pig traps and regulators and more. And the rig's going to be made from a range of pipe steel grades up to X80, initially from a 250 metre long length with block valves, and then up to a full 1 kilometre pipeline with the ability to pig it and inspect it. So phase 1B, we will inject hydrogen into that network, and that will be blended with natural gas to provide a range of compositions up to 100% hydrogen. And we'll consider concentrations such as 2%, 20% and 100% hydrogen, with intermediate concentration studied as necessary. We'll operate the facility for around 6 to 12 months following the detailed master plan that will be created in the current Future Grid Network Innovation Allowance project. We'll then review and evaluate the test results using research from Fluxys. So I've mentioned that we're collaborating with NGN already, but we also have a number of other partners for the programme, including Fluxys. Now, Fluxys own and operate the transmission network in Belgium, and they're at a similar stage in their hydrogen research as National Grid is. They have a similar network composition, and we've identified opportunities to collaborate with them and share some of our applied research to improve the efficiency and maximise the benefits of phase 1. Fluxys have an established relationship with Ghent University as well, who'll deliver aspects of their research programme for them. Now, Fluxys are going to bring the following core areas of research to the Future Grid project. Now, the first area is material characterisation. So assessing behaviours of materials when exposed to hydrogen will be critical when assessing the risk of repurposing assets. And Fluxys, through collaboration with Ghent University, will conduct a microstructure analysis and fatigue testing on more extensive sets of assets, including pipeline welds, to extend our data set and learning across a wider portfolio of assets. Now, the other area Fluxys will provide is something called a fast screening methodology. So building on the materials characterisation testing programme, the team at Fluxys have proposed to develop a fast screening methodology to take all known parameters of an asset and extrapolate that across the full range of assets within our network. And this approach will complement National Grid's asset readiness developments as we develop a full asset risk model for hydrogen. And then finally, we'll validate flow parameters such as gas velocities, pressures, and energy delivery. Finally, phase 1C, that will provide a high-level assessment of the public safety impact. We'll look at an updated hazard assessment of the national transmission system. Undertaking a quantitative risk assessment as well, we'll identify whether the existing methodology is fit for purpose. We'll also look at overpressure risk and whether that area needs to be updated, and if so, develop an appropriate methodology for risk analysis and emergency planning purposes. And then finally, we'll look to update the national grid safety case as required for hydrogen. So we have a number of partners for the programme, and I've mentioned some of them already. DNVGL are our main delivery partner. The Health and Safety Executive Science Division are supporting the development of the test facility and subsequent master test plan. I've mentioned NGN and Fluxus. Durham are going to be sponsoring a secondment student to study gaps in our National Transmission System programme, and the University of Edinburgh will be supporting the trials and developing technical papers and research to enable the dissemination of the learning. So I also want to introduce you to Project Union. This project is in the very early stages of development, but it is an exciting project and one that aims to support industrial decarbonisation. But before I go into detail of that project, I just want to mention the publication from Guidehouse, so their European Hydrogen Backbone research study. Now, this was published in July. It's a proposal by 11 European gas infrastructure companies, largely based on using existing gas grids. And the proposal is heavily based on company insights and research groups that they set up over a number of weeks. Now, this slide shows the map of the hydrogen backbone as it will stand in 2040, according to their proposals. And by 2040, there would be a 23,000 kilometre network consisting of pipelines in various dimensions. And by 2040, their report suggests that it would be based on around 75% repurposed assets and 25% new pipelines. So the range of those pipelines include 24 to 48-inch pipelines, and the total cost is around 27 to 64 billion euros to build. And that price difference is largely related to compression costs. They foresee work starting in early to mid-2020s, largely creating networks between industrial clusters. And by 2040, you might be able to see on there, they're indicative lines to the UK. So this could emerge before 2040, and they would connect in at Bacton where there are existing interconnectors today. And while this wasn't explicitly analysed, it's interesting for us to look at as we understand our own transition, and we do work around the Bacton area and look at decarbonising the east of the UK. So Project Union. Project Union looks to review the potential for repurposing national transmission system pipelines to create a UK hydrogen backbone equivalent. So very similar to what I've just explained has just come out of Europe. And this will connect the UK's largest industrial clusters. So connecting the clusters would help to provide resilience, and where there's potential for excess hydrogen generation in a cluster, the NTS could transport the hydrogen to different demand centres. Now, we've highlighted on this particular map various potential pipelines that we're considering, but there is more analysis required to understand the impact of removing these from the natural gas network, particularly in the transition, and understanding the ordering of what that might look like. And some areas of the network may be more difficult, particularly the more meshed areas in the centre of the network, and we'll need to think about how this may be managed against different future demand levels. But it's an exciting project in its early stages. There's also a natural link with this project to Project Cavendish, and National Grid has been out talking about Project Cavendish in the past. So Cavendish looks to reuse assets in the southeast of the country and in the London area for hydrogen, and this is bringing hydrogen in from the Isle of Grain. And in the early stages, it will look to use methane reformation with the potential to switch to green hydrogen as production prices drop. There are potential pipelines in the Bacton region where we could connect the network to this hydrogen backbone as part of Project Union and provide further connections to Europe. So again, early stages, but just thinking about how Project Union connects to some of the other existing projects around the UK. So to summarise, we're progressing well in our repurposing approach. We now need to do scales-up trials and move away from desktop studies, and this is where Future Grid comes in. We believe high levels of repurposing is possible, and we've seen that from a European perspective. We've seen that the national transmission system at a high level appears to have the capacity required to transport hydrogen in 2050, and our strategy is emerging for the national transmission system. So thank you very much, and thank you for your patience with me dropping out earlier on. Appreciate your time.
Thank you very much, Danielle. Always difficult having to give a presentation twice, but it was very clear and very indicative of a huge level of work that is now emerging out of National Grid. A couple of questions from me, really. What do you need from the regulator to help you move what sounds like a very pragmatic but ambitious work program forward. And then the second question is looking medium to longer term, and the hydrogen backbone project, which clearly would make sense in an integrated Europe. And I'm not asking a question about Brexit or anything like that. But why is it so caveated around UK involvement when obviously there are the existing interconnectors, which I would have thought made a very obvious key element of the project? So 2 questions there for you.
Perfect. So I'll start with the first question, and what we need for the regulator in the short to medium term. So I think over the next 5 years, building that evidence base for hydrogen is going to be critical. Otherwise, we're going to miss the boat. We need to start soon if we're going to transition to hydrogen for the long term. That means that the next regulatory price control period is going to have the right framework to enable flexibility and for us to deliver some of this work at pace. And at the moment, there's a number of mechanisms for doing that. There's upfront baseline funding that we can apply for. And in our business plans, we haven't got much of that as part of the National Grid submission. But we have applied for a certain amount of innovation allowances. So the right innovation allowances need to be there with the right criteria that allows us to do the kind of work that we need to do to look at this hydrogen evidence base. There's a number of mechanisms that Ofgem have proposed in their draft determinations, all with the aim to provide that flexibility that's needed. We do believe there's a lot more work to do in making sure that they do provide that. So the right levels of funding, the right levels of flexibility, and the right level of pace and ambition from the regulator are all things that we need to look at. There's a number of mechanisms that they have proposed for being able to go back over the next 5 years and request allowances where appropriate to do so. That's very useful, and I think that's something that we need to make sure is appropriate for all networks to be able to apply for, and also allows for a whole system view of what the next 5 years look like. The challenge we will have is making sure there's certainty. So investors know where they need to, that we are an investable organisation, and the work that we're doing does have a long-term future. So there's a number of things we need to think about in the next 5 years. Looking forward, longer term, so you mentioned the piece around Bacton and ProjectUnion and connection to Europe. So National Grid and the UK weren't involved in this particular study at this first stage, but we would look to get involved in the next stage of this study. So I don't think there's anything that says that we shouldn't be looking at this now. We absolutely are, but it wasn't as part of that study that we've seen to date. So we are in conversations with Guidehouse and Gas for Climate, who commissioned this particular study. We are looking to work with them going forward, and we're in conversation right now.
Good. Well, 2 very clear answers. I think I share your views about there not being sufficient clarity in the price control reopening mechanisms, and a possible reopening at the regulator's call is not the right way to reassure the market at a time of very brittle confidence in new areas of investment. And it's good to hear that there's further discussions coming on around the backbone, because Bacton has to be part of it, and that's not because it's kind of over there beyond Norwich. But thank you very much indeed. We will now move over to our next speaker. Right, I believe we're live. I think. In adversity comes opportunity. We're going to start our second panel, our second slot, our panel discussion. I've got 2 of our speakers here at least. Eric, can you just confirm whether anybody else will be joining us? But for present purposes, I've got with me Professor Peter Taylor, who is Chair in Sustainable Energy Systems at the University of Leeds, and Philip Brain, who is Business Development Manager of Hydrogen at Kiwa. They will introduce themselves in a moment, and then I will ask both of them to just make some introductory remarks around our theme, which is prioritising decarbonisation in industry using hydrogen and the interactions with domestic heating and use of hydrogen as well. So, Professor Taylor, over to you.
Thanks very much, Nigel. Yes, so I'm Peter Taylor, Professor of Sustainable Energy Systems at the University of Leeds. And really, I take a whole systems kind of perspective. So I'm really interested in how hydrogen fits in with a bunch of other technologies that might allow us to get to net zero. And I think it's really interesting if you look back, say, over the last decade about how the narrative on decarbonisation has changed. So if we go back, say, 8 or 9 years, then in terms of decarbonising heating, people were talking a lot about electrification and about heat pumps. And then we began to realise exactly what that might mean for future electricity demand and the strain that might put on the electricity network. And therefore, there was a greater interest in how we might decarbonise gas by introducing hydrogen, either as a small share, say 20%, or eventually fully shifting over to hydrogen. And therefore, I think we've essentially now we've got these two options which are on the table, and I don't think there's a clear winner from those. It may be that we have different options in different parts of the country. But what I think has changed more recently over the last, say, 18 months since the net zero commitment by the UK government is the recognition that we will need to make much more substantial reductions in emissions from industry. So if one looks at the kind of analysis that was being done for the old 80% target, then people were thinking, well, maybe industry might have to reduce CO2 emissions by perhaps 50%. Now we're probably looking at much more like a 90% reduction. And with such a significant reduction in emissions from industry, then I think hydrogen really comes into play. And I think it's an interesting proposition that it may be the need to decarbonise industry that perhaps might be the main driver behind the early deployment of hydrogen rather than the decarbonisation of homes. But perhaps that's something that we can discuss as part of this panel. So thank you.
Good. Thank you, Professor Taylor. Philip Brain, I'll ask you to just respond with some opening comments, and then I'll introduce our other two panelists who've now joined us, the cavalry.
Yeah, sure. I'll try and keep them brief. To respond to what Peter was saying, Kiwa's focus tends to be on the downstream side, on the usage of hydrogen, but we have started to get increasingly involved in feasibility projects for what are variously called hydrogen hubs, hydrogen valleys, depending on your audience. And as such, we're very much into the journey of discovery, which is matching variable sources of demand with a multiplicity of options for production, storage and distribution. And to reinforce what Peter was saying about a whole systems approach, you really do need to understand each of those elements individually and how they complement each other, including electrification, in order to be able to design your system. And it's a very complex thing. James Thomas will be presenting on that later in a bit more detail, but that's where we're coming from today.
Okay, thank you very much, Philip. I'd now like to introduce Angela Needle from Cadent and Nigel Holmes from Scottish Hydrogen Fuel Cell Association, both of whom I've had dealings with in over recent weeks whilst we've been finding our feet at Hydrogen East. Welcome. We're going to be talking about the different uses of hydrogen, where the priorities should be and could be. But first, could you give some initial comments on the changing agenda and the increased emphasis that I personally believe is rightly being placed on hydrogen? Angie, do you want to kick off?
Yes, thanks, Nigel. Can you hear me okay?
Yeah, loud and clear.
Can you hear me okay?
Yeah,
Great,
loud and
okay.
clear.
So yeah, I'm Angie Needle from Cadent. There's a big delay. I'm a Cadent Strategy Director, and I'm responsible for thinking through Cadent's transition from being a company that delivers fossil gas to people's homes and businesses to how we transition the infrastructure that people have already paid for to make best use of how we transition to net zero. And so that includes hydrogen, of course, in that mix, as well as biomethane and other green gases. And so there's really been a very big step change in people's views on hydrogen. And for me, that's just largely because of the net zero target by 2050. So that 20% that was everybody else's problem can now be solved with hydrogen. And it was really very difficult to think of how you could electrify your way to net zero, or whilst I still think that is possible, by the way, in the long term. I do think there needs to be a role for other types of energy vectors in the system, of which hydrogen is one of those. And if we think of it as a vector, you have to make it, you can transport it to wherever it needs to go with a distribution system. And I do think there is a merit order, on where hydrogen should go first, second, and third. We're, of course, focusing quite a lot on what it means for heating in homes, but that's largely because it's a really big problem to solve, and it needs lots of different solutions. And we need to think about what those solutions are now, so that we can come up with the best thing that means people are still kept warm, right, all year round, which is the ultimate aim, and that consumers are protected in that process.
Okay, thank you, Angie. Nigel, do you want to make some introductory comments?
Thank you, Nigel. And yes, so I'm Nigel Holmes. I head up the Scottish Hydrogen and Fuel Cell Association. And yeah, I'd just like to sort of build on some of the comments already made. So yeah, Phil mentioned the importance of looking at the whole energy system, and I think that's absolutely critical. We're going to reach net zero. We can't just pick off parts of the system. We've got to look at it as a whole. And the goal for hydrogen appears to be increasingly to tackle the hard to treat areas. So heat duty transport, high grade process heat for industry, heating for homes, the traditional homes that have very high spiky energy demands, are all areas that hydrogen's been considered as the solution to the problem. And Angela mentioned about hydrogen being a vector. It is indeed a vector, but a vector with a difference. And the key difference is that with hydrogen, we have the opportunity not just to move the clean energy around, but actually to store that energy and to actually allow us to match the production of intermittent renewables onto the variable demand. And this is where industry homes are very different. Industry is often a nice steady baseload of energy requirements. Heating from homes is extremely peaky, especially in the winter. And it's not just seasonal variations in demand that make the difference. It's actually the change in demand throughout the day. So often at the start of a cold day, the amount of energy required to essentially boot up everybody's central heating when it's cold is quite awesome. And I think this is something that hydrogen do very well. And as Phil mentioned, we can look at this in the complementary aspect of hydrogen to other forms of low carbon heat, but recognize the key strengths where hydrogen will play a part.
Okay, thank you very much for those introductory remarks. I guess an obvious question is, given a high level of consensus about the need for hydrogen and what I think is now seen as quite a big gap to fill with the shift from an 80% target to net zero, how should the government set about tackling this? You're all involved in your individual work streams and activities, but what does the government need to do to put us on a consistent pathway to realising the potential of hydrogen. I'll ask Professor Taylor first, then Philip, then Angela, and then Nigel Holmes, in the order that we've just been through the introductory remarks.
Thanks very much. Well, I think actually we've seen quite a lot of activity recently that is heading in the right direction. So perhaps if I take the use of hydrogen in industry first of all, so we're beginning to see quite sizable sums of money coming forward from the government for decarbonisation demonstration projects, particularly in the big industrial clusters. And often that would be hydrogen linked with CCS as well, which is obviously another important technology for decarbonising industry. And so I think it's very important that we get that those demonstration projects up and running, and we can learn from that, and we can learn about the different applications of hydrogen and how we might use it in industry. And it's already been mentioned, particularly I think it's got a role for high temperature heat and direct burning in kilns and furnaces and things like that. And that also enables a level of demand which can help the supply side, so we get our supply side sorted out. And although that's not the focus of today's session, I think that will play an important role potentially also in the acceptance of it in homes. I think while hydrogen is linked with fossil fuels, if we're making it from natural gas, then some people might be concerned that that's not really part of the kind of long-term energy transition that they want to share in. If we can demonstrate electrolysis at scale and get the cost of that down so it can compete somewhere near the cost of steam methane reforming, then I think we'll be in a good place. I think on the home side, obviously there's been a lot of work done, as we were hearing earlier, by the various network operators in testing their networks. What we need, obviously, is those appliances to be available that either can use hydrogen, in a dedicated way, or at least are hydrogen ready. And we are seeing some progress on that. Again, there have been various government programs which have funded some development of boilers and gas fires, and I think that's extremely important. Although at the moment, I think we're at the situation maybe where there might be one or two models on the market, and clearly, if you're going to go and buy a new gas boiler, then you have a whole range of different models that you can buy from different companies with different appearances and different specs. And I think we really need to be getting to that stage with at least the hydrogen ready appliances, so that consumers have a choice. Because we need to remember, I think the evidence from surveys that have been done is that most consumers don't actually realise what gas they're getting now. They don't know that it's methane. And so in a way, they perhaps are not all that concerned if it turns out to be hydrogen at some point in the future, as long as they can run their heating system pretty much in the way that they do now, as long as the price is right, and as long as there's a disruption for the change from natural gas to hydrogen isn't too great. So I think those are all things that we need to be thinking about.
Good. Philip?
Yeah, I mean, Kiwa is a notified body for testing domestic and commercial gas-fired appliances. So we're very familiar with that market, and we're also technical advisors to the IFA Heat Programme. So we're very familiar with the verification process of milestone achievements during the product development phase of both domestic and commercial heating and catering and cooking and appliances. And yes, Peter, you're right. There's a couple of boilers, well, both of boiler companies, both of which are producing a system boiler and a combi boiler for use with hydrogen, that are at a phase of development, which is what we're saying is demonstration stage, so TRL 6, 7 at the moment. And they're looking to be commercially viable and able to be sold and certified as being sold on the open market by the end of next year. So that's to give you an idea. And there are cookers, which there are some excellent developments in that we're seeing as well, and likewise even gas fires in people's living rooms and so on. So the appliances are coming on. So actually the technical bit is being addressed. The other, obviously, the bit that everyone forgets is the meter. Those are also being developed, because hydrogen is a much lighter gas than in energy terms than natural gas, and so you need effectively 3 times the volume of hydrogen to burn the same amount of kilowatts through your appliance. So you need a different form of metering, or 3 times the size of a volumetric meter. So we've gone away from the volumetric meter to look at ultrasonic and calorific value meters, and those developments are coming on as well. Another area where people which is the bit that people forget, are standards and training. Those are the 2 absolutely critical areas that HyForHeat's been working on as well. iGEM have developed a reference standard that others can use. BSI have referred to that reference standard in developing a testing standard for hydrogen appliances. EUS are looking at a training conversion standard for domestic and commercial properties. I know that the H21 projects are looking at how that applies to networks, and EUS are working with them separately from HyForHeat on training. So all of these standards are starting to be developed, which is great news. And the training of people is coming on as well. The difficulty with training and actually even the development of standards is you need a market, because until you have a defined market, then people are not going to want to get trained, because they could get trained, wait 6 months, forget everything they've learned, and then they have to go and get retrained. So the only thing really that's the critical piece in the jigsaw that's missing at the moment, I would say, and I know Angie would support this, is a hydrogen strategy from the government. And I'm not just talking about a plan to spend money. I'm talking about, give us the rules by which we can trade hydrogen over the networks. Give us an understanding of the kinds of projects you want to incentivize and why you want to incentivize them, in terms of, is it carbon saving? Is it cost reduction? Is it a particular, without even choosing technologies and so on? And give us a joined up strategy that complements electrification as well as other forms of decarbonised gas. And all of that, and is extremely complex, so it's not an easy task. I know I'm asking simple questions, but I believe they've started the work now, and we should hopefully see something in the new year. Anyway, at that point, I think I should hand over, because I've been talking long enough.
Okay, so really you're saying that it's the regulatory piece and,
yes,
and the overarching safety case.
Yeah, it's market design and followed by market support mechanisms, which come from incentivizing the right kind of market behaviours.
Okay.
And some of that might initially be pump-primed by grant funding of small projects, but in the long term, that will be to lever in private investment.
Okay, that's clear. Angie, do you agree with that?
Yeah, I totally agree. So I talk about this quite a lot, as you know. So hydrogen's a race, you know. It's a global race, you know. And where do we want people to invest? We want people to invest in the UK, and we don't want them to give their money to Germany or France. You know, we want it to come here. You know, we want the UK to be a hub for Europe for hydrogen. We've got plenty of offshore assets to generate hydrogen. And we've, as Phil's quite eloquently articulated, you know, technically speaking, all the problems can be solved. And so it really does come down to, and very simply for me in the short term at least, is we need to make some hydrogen. Right? So if you get some hydrogen being produced, either for industry, so you can demonstrate fuel switching from an industry point of view, you've got sufficient hydrogen then to be able to do the demonstration projects, to test and pilot your appliances, to be able to show how a transition can happen for a community or a housing estate. At the moment, we can't put hydrogen in the gas grid at all. And we're working on the sort of rules and regulations that sit behind that. So actually setting out this strategy in the new year is really important, because it will really establish the UK as sort of pace in relation to hydrogen, and it will attract investment. And I think that is what this really needs. It needs funding now. We can't sort of continue making a hydrogen future happen on grant funding alone. So I'm really very supportive of the work that the government's doing. They're putting some pace into it. They're progressing with quite some urgency, which is really helpful. And actually, it's quite complicated because, as you know, hydrogen covers a multitude of different industries in terms of not only industrial decarbonisation, but transport, heating in homes, power generation. So it's very difficult actually to put together a strategy that covers all those things and keeps everybody happy. So I do understand that they're working on that at the moment.
Okay, that's very clear. Nigel.
I think the comment that it's difficult to put together a strategy and keep everybody happy is actually very accurate. And it's probably worth reflecting on some of the strategies that have been put in place already. And take Germany, for example. So their strategy was published at the start of June, but it was actually due to be published late last year. And the reason it took time to actually be released was that, as I understand it, there was a big debate in Germany about the relative merits of green hydrogen on one side and blue hydrogen on the other. Blue hydrogen seen very much as the way to address the economic challenges of decarbonisation, but green hydrogen seen as being the sustainable long-term goal. So how do you start to square off these what appear to be conflicts? And quite rightly, Germany has come to the conclusion actually it's not one or the other. It actually needs both green and blue hydrogen in the first part of their activities to really start to tackle the challenge around decarbonising industry at scale. And again, I think what is very telling is that I think it's not just looking at how they decarbonise industry, but it's how they actually retain industry in Germany. So looking at steel, the manufacture of steel, and converting one of the biggest steelworks in Europe to run on hydrogen is actually an activity that is being undertaken by ThyssenKrupp. If we look at the Netherlands, their strategy was put in place in May, I believe it was, and the activities that are starting to develop in the North Netherlands are driven to a large extent by necessity, by the closing down of the Groningen gas field and the need to find an alternative feed for industry. So a real sense of urgency in Netherlands that is driving the pace of change and some of the innovative ideas that are happening. France came out quite recently. Europe has its own strategy. So these strategies undoubtedly take time and effort to put together, but they are already in place. And Scotland, we are getting close to actually having the hydrogen policy for Scotland released. It will be out this year, and that will be linked to the hydrogen action plan. So I think the point I would make here is that making a hydrogen strategy can be done. There are plenty of examples out there. Hopefully we can learn from the experience that other countries are having. But we also need to reflect very carefully on if these countries are already established with their strategies, then what part can we actually play, or how can they potentially help us? Where is an area of potential joint activity? And post-Brexit, I don't think means post-trade. It does not mean post-cooperation. And so I think we need to look very carefully at how those links can be established and used to everybody's benefit going forward.
Okay, and of course in Scotland you've got quite a, I would observe, a progressive government that's trying to formulate a strategy. Are there things that we should be learning from you? Without getting political?
I wouldn't want to presume that sort of the stuff we're doing in Scotland might be relevant to the whole of the UK. But I would point towards examples of where we have some very well established clusters for hydrogen activity on different levels. Aberdeen has been very successful with the early work on the hydrogen bus project. More recently, that's developing into a energy transition play for Aberdeen. So Aberdeen wanting to change from being the oil and gas capital of Europe to energy, or the low carbon energy capital of Europe. And again, driven by necessity. Will the drop in fortunes of the oil sector mean that companies now have the opportunity to transition to become part of the low carbon hydrogen supply chain. And I think that is indeed the case. The work in Orkney is very different. Projects like Surf and Turf and Big Hits have demonstrated how you can actually develop hydrogen clusters. And the importance of a cluster is that you're actually creating the production of the hydrogen, demand for the hydrogen, and the infrastructure that brings the two together all at the same time. It's a bit like what we're trying to do with the hydrogen economy in a country, is to actually boot up the economy from scratch. But we need all of these respective come together. And I would suggest that that is exactly what is happening in projects like Orkney and Aberdeen to an extent. Fife has also been an area, and coming back to the importance of early projects, Angela mentioned that. One of the key projects I see for the UK is the SGN H100 project, which will build on some of the previous work started by projects such as HyDeploy, and actually move towards creating a 100% hydrogen network for 300 or 400 homes. I think, Phil, you're quite familiar with some of the plans on this one as well. And a key part of this project, we must always include when we're talking about strategy, is how we get the general acceptance from the consumer that hydrogen isn't something that's just going to be forced on them. It's something that they will have choice. Do they want to choose to use hydrogen for low carbon heat, or do they want to choose to use electricity for low carbon heat? Having these choices and making sure that the consumer is comfortable with making these choices in terms of understanding the technology, the disruption, the costs, and anything else that goes along with the selection of what you might want to do, both in terms of your household heating, or indeed for your transport, or how you might start to select the products that you buy. How are they made? Where's the energy coming from? So there's a whole host of factors that come into play, and all of these ultimately have to be reflected by governments in terms of policies.
It all sounds quite a big job. I mean, I'm very familiar with the smart metering program, where officials have made certain assumptions about what people want, and that hasn't always proven to be the case. So that leads me on to ask, how can some of these very fascinating work streams, and we haven't talked about transport, which is the theme of the fourth seminar in the series, how can all this be brought together in a more coordinated way, or should we be looking at these little pockets of locally driven activity? What is the right balance, and how can we share learnings? Professor Taylor.
Yeah, so I think we need a combination, as has been pointed out earlier. I think having the high level government strategy in place with the, so we're clear on the direction that the government wants to go in, will be important. But equally, there is no substitute for demonstrating these projects on the ground, whether it be in industry or in homes. So I think that the challenge that we've got really is one of time. The fact that the net zero targets for 2050, that's not that far away when we're talking about these big infrastructure projects. So we need to get on, and we don't have the luxury perhaps of doing things in the kind of sequential way that we might wish to ideally. So we need to have the top level direction, but we need very much also to have the demonstration on the ground. We need to be able to create the markets. We need to have the equipment that people are going to be using. We need to bring on the sources of, as was mentioned earlier, blue and green hydrogen to meet that demand. But I very much see it as a kind of an all hands to the deck kind of approach to get this to the level it will need to be in a relatively short period of time.
A little call out for yellow and pink as well, unless we forget those. Philip, have you got any thoughts on this?
Yeah, I was reflecting on what Nigel was saying about the various European national strategies. And the thing that stood out for me with the German strategy is the the close cohesion between regional strategies like Bavaria or North Rhine-Westphalia and the national strategy. And I think if we could repeat that in the UK, then we would do things like complement Scotland's enormous potential resource for offshore wind and hydrogen production, but total lack of geological storage capability, with some of the geological stores that are available around the rest of the UK and transmission lines that allow those two elements to be linked together. The other thing I'd say is, I was talking about standards earlier. Standards don't get developed in a vacuum. They have to be informed by small projects. So again, reinforcing what Nigel was saying about investing in small projects to learn lessons that allow you to set the rules for incentivizing bigger projects. And the real cost reductions, we think, will come with scale, particularly on storage. Cost of hydrogen is very sensitive to storage. Scale. And it's very expensive at local level.
Angie, maybe could I ask Angie if you could pick up maybe and say a couple of things about your very good report that you issued last week from Frontier and calling for 20% blending?
Yeah, so we've been looking at blending hydrogen into the gas grid for some time, because you can use your existing infrastructure and you could immediately decarbonise a proportion, albeit small proportion, of any natural gas use today, without impacting on users in terms of their need to change metering or appliances or things like that. And the reason why it's important is it creates a stable demand centre for production. So if you can get blending going, you can learn quite a lot in that process of how you might do that at scale. So we've demonstrated at Keele University, they've got their own gas, green hydrogen, injecting it into their gas grid, and they've been using it on campus in the homes and buildings in the facility there. There isn't any discernible difference in the comfort levels, if you like, and the use of the appliances. We've got a bit more running to go because we had to pause for COVID. No gas was being used on site, but it's back up and running again now. So we've got a bit more of winter to go to test those appliances. So from a technical side of things, we can achieve blending of hydrogen. From a commercial side of things, which was the Frontier report that we produced last week, is actually more important. So we're good at demonstrating you can technically do things because we're an engineering business, but actually it comes down to how do the commercials work, what kind of governance sits around that, how do you manage the entry and exit of hydrogen into the system so it stays at the right level, how do you make sure consumers only pay for the energy that they use, the kinds of regulatory and policy type things that need to be established to set up the transition to hydrogen. And so we're very supportive of the steps that government might take. And I think blending is being considered as part of the hydrogen strategy. So, that will really unlock production. So, what we really want is a place for producers of all kinds, small or large scale, to feel confident that there's a retail market for hydrogen, and this would establish that.
Okay, thank you very much. I think we're coming up to the end of our time. I will conclude by asking each of you, what is your single big ask of government when they issue a strategy in February? What do you want to see top of the list? Nigel.
No pressure. So I think for me, the big ask for the strategy is that we actually need to be explicit about the carbon footprint of the hydrogen that we produce. You mentioned pink, yellow, we also have green and blue. I think for the consumer, actually also for delivering the targets, we have to be totally clear about the whole carbon footprint. So This isn't just the source emissions during the processing to actually produce the hydrogen. It's actually going back into the full scope. Why? Because we've seen many times with other technologies that it looks very attractive to start with, but when you start peeling away the layers of the onion, you find that it's actually not quite so pretty. So we need to understand that right from the start. And the other reason for doing this is that I think by understanding the footprints, we can actually then start to make sure that we can provide industry in the UK with the source of low carbon energy, and hopefully at the price that it needs to be to keep UK industry competitive.
Good. Professor Taylor?
Yeah, I think the issue of cost is a very important one. So I think it needs to be clear what government expectation is about what what they want for the cost of hydrogen and how they're going to enable it to reach that cost, and what support measures they're going to put in place to ease that path. Because over time, as we get economies of scale, I think that costs will fall, but initially it's likely to be much more expensive, and particularly if we're looking at homes or industry, the implications of additional costs are quite stark. So in industry, obviously they'd be worried about competitiveness and the potential for carbon leakage. And for homes, it's really important, I think, that we consider the more disadvantaged sections of society, the fuel poor, and perhaps there we need to be considering wrapping up a big energy efficiency retrofit program alongside our introduction of hydrogen to mitigate the impact on bills.
Okay.
So I'd like to see a bit of energy efficiency go alongside the hydrogen as well.
You'll have to convince your Electrify Everything colleagues about that, I suspect, but I fully agree with that. Philip, any final big asks?
Yeah, so first thing is, whilst we have a relative lack of information, we need to learn by doing. So invest in small projects to start with that are going to be informative and are easy to see the results being scaled up. And the second thing I'd say on costs is transparency. A really good analogue for where we are now is the offshore wind industry about 10 to 15 years ago. And the reason why the offshore wind industry was able to reduce its costs so rapidly is because there was general agreement on the rules of what levelized cost of energy, how that was reported, and therefore what project costs look like in a standard across the board. And that's bear in mind, that's in an industry where costs vary massively depending on where you put your wind farm. So there are, even with industries where there are lots of variability between projects that are location dependent, it is still possible to have a standard for declaring costs in a transparent way. What that allows you to do then is to set a national framework for firstly accepting the initial costs as what they are, and then spotting cost opportunities by comparing projects against each other, and then incentivizing those cost reduction behaviors.
Okay.
So transparency is absolutely key, and that's more of an appeal to the industry. And we've got our own little SMR project being developed at the moment down in Cheltenham. We intend to be utterly transparent about the costs of that capex and opex, because we are doing what we say as well as what we asking others to do as well.
Super. And last but not least, Angie, do you want to set out your shopping list?
Yeah, I'm not going to ask for a shopping list. I talk about my shopping list quite a lot. So I think what's needed is just ambition, right? So I worry that we'll, cross things off because we just want it to be perfect. We don't need a perfect strategy. We need one that sets out some goals that are ambitious enough to set us on the pathway to net zero, that work collectively with other bits of the net zero, strategy, which is important, but it won't answer all questions, and we'll be waiting for quite a long time if it does. But I would like it to be stretching enough to really, give the UK something to focus on, in addition to all the other things that we need to do to get to net zero.
Okay. Well, thank you very much to all our panelists. High level of agreement that technically most of the challenges are at least known. but we need to have clear targets, a level of ambition, and some ability to translate learnings into other programs. So on that note, I will conclude this session, and thank you very much indeed. And I think we're going to be able to resume now with Danielle from National Grid. Is that right?
Great.
Decent size, yeah.
Okay. So yes, good to talk with everyone, and some interesting panel discussion. I think really setting the scene for what's happening in hydrogen at the moment. As Nigel said, I'm from Progressive Energy. I'm actually at the moment acting as our program and commercial manager for what we call our HyNTS industrial fuel switching program. That is part, I guess, one of the supporting elements of the wider HyNTS project, and I'll talk about how those fit together in a second. Progressive is leading the overall development of the HyNTS Northwest project, working with a range of partners, including Cadent. We had Angie Needle talking this morning, and Cadent is developing the hydrogen pipeline network element of HyNTS. Just very briefly, some of you will have seen this map schematic many times, but just very briefly, you see this is the Northwest. You can see Chester, Liverpool, Manchester on there. We chose the Northwest for HyNTS largely because of the sort of natural assets associated with it, close proximity to offshore CO2 storage reservoirs in the form of depleted gas fields, and close access to the Cheshire Salt Basin for storage of hydrogen. Both those being critical pieces of infrastructure and giving us what we think is the lowest cost location for a hydrogen and CCS project in the north in the UK. It's worth saying there's a discussion about sort of blue and green hydrogen this morning. I think Chris Stark made an interesting comment on his Twitter feed the other day. It's to say it's and not or. I think whilst we are developing a blue hydrogen project in HyNTS, the critical thing for us is to put down a hydrogen network, a hydrogen pipeline network that significantly reduces the costs of moving hydrogen. As I'll talk about in a minute, I'm running demonstration programs, and moving hydrogen around in tube trailers is hugely expensive, and getting a pipeline network will enable green hydrogen in the future to plug into that network as biomethane plants do today into the natural gas network. So just in terms of HyNTS very briefly, we've got, obviously, when we're talking about the industrial element with it today, we've got the hydrogen production plant at the centre. We're developing that with partners at SR's Stanlow refinery. Ultimately, we put natural gas into that hydrogen production plant. It's using something called autothermal reforming technology, which is part of Johnson Matthey's low carbon hydrogen technology. We have coming out of the plant, we have obviously the CO2 pipelines and the hydrogen pipelines, CO2 being the orange ones on the diagram, and the hydrogen pipelines being the black. We have a hydrogen blending element to the project. I won't talk too much about that because I think we've got limited time, but that is part of our HyDeploy project and what we're demonstrating at Kiel at the moment. I think Angie mentioned that this morning. We also plan to deploy a further demonstration called HyDeploy 2, which will supply about 1,000 houses, which will provide the evidence for us actually doing this for real in the network. We also have a power element to HyNTS and a transport element, so putting hydrogen into for flexible power and into the transport sector. I'm going to be talking about industry and the role of industry. I think critically the way industry fits into this, industry has a relatively flat demand for hydrogen. That gives us, or I guess it minimises effectively the amount of hydrogen storage that we need, therefore reducing the costs of the project. But also those large industry sites that we're working with give us sort of anchors for demand and effectively enable us to finance the rest of the infrastructure, including the pipeline network. Just very briefly, magnitude of of capital spend on HyNet. First phase, there'll be about 3 terawatt hours per annum of hydrogen. It's about a billion investment. We've been pretty successful so far in raising development funding, but to actually raise this amount of capital funding, as people mentioned earlier, we really need the long-term policy support mechanisms, whether that be a CFD for hydrogen production and use, or the funding mechanisms such as putting investment in hydrogen pipeline networks under the regulated asset base of the network operators. So we need that. We've got a lot of capital to raise. We think it can be raised. Industry stands ready to invest, but government needs to put those long-term mechanisms in place. Just very briefly, in terms of the different elements and the timeline, we're aiming to reach a final investment decision in 2023 and start operating by the end of 2025. So with HyNet, the sort of first couple of sort of top bands you can see there around actually development of the project. So usual project development, consenting, financing, permitting, all engineering design, all that good stuff. We've also got the sort of second bar. It's difficult to point to things in this environment, but the HyNet evidence programs. I've mentioned HyDeploy. What I'm talking about today, our industrial fuel switching program. So those are effectively part of HyNet, but they are developing the sort of evidence and demonstrating we can do all the things that we want to do, particularly around hydrogen use. Just very briefly, again, give you a picture of the industry. Engaged with about 30 industry sites over the last 4 years since I've been involved with the project. And we have, I guess, a sort of phased program of conversion for the sites, the sort of green dots that you can see on the chart there. So we are sort of actively working with a number of those sites, including those that we are working on the demonstrations with at the present time. So the HyNet fuel switching program, it is a program that's been funded by government, by BEIS. It's a 5.3 million program. I think we received notification of funding around turn of the year. Signed a contract shortly afterwards. The objectives of the program really are, as I said, to provide evidence. That's not only to enable the participating sites to convert to hydrogen as soon as it is available from HyNet, but also so wider sites in the northwest, but also beyond across the UK can convert as soon as hydrogen is available. So there's a and I think, as I'll talk about in a second, one of the sites we're working with, it's a very ubiquitous technology that we're converting, and I think, you know, if you demonstrate you can do that, then that will enable industry and commercial sites to convert in the future. The other objective, in line with our contract with BEIS, is to determine the costs of converting to hydrogen. As the words say there, in most industries, it's conversion rather than the need to buy new plant and equipment. And it's actually relatively cost effective to convert in many industrial sites, not all, but if you're looking at, for example, sites which have boilers in place of one kind or another, or even furnaces, often we're just replacing the burners that are associated with the boilers and other equipment, and it's relatively low cost to do that. We're tweaking things in producing new burners to actually reduce NOx and things like that, and enable a different kind of burn associated with using the different gas. The other objective is to prove that there's no detrimental impact on existing plant equipment, as you'd expect. Hydrogen's got a longer flame, greater flame speed. There's more moisture content coming out of the flame, so it's actually making sure that we're not going to people aren't going to damage equipment when burning hydrogen, and that's critical in these demonstrations. And I should say, you know, we're running these at live sites that are manufacturing product at that time. Therefore, you know, we can't cause any damage, but to prove things in that environment is very important. And yeah, obviously we want to demonstrate hydrogen can be used safely and in conformance with all related regulations, and that to demonstrate that we can use hydrogen permit very, and I think certainly in the case of the demonstrator need to vary permits at all, and we are burning quite a lot of HyNT. What's the structure of the fuels of the HyNT? We've got us at the top. We're to bays. We've got our work hydrogen supply. We've got a TBC there. I would say actually probably the most surprising thing about this whole program, we've been working on it for the last year, is actually one thing I hadn't thought would be the biggest challenge, but is actually to get sufficient hydrogen into the program at the right commercial terms. There's not a lot of hydrogen around in the UK, and I mentioned before, moving it is very expensive. We're used to sort of moving, petrol and diesel around in trucks that carry around 30 tons. You've got the same sort of truck with a tube trailer truck carrying hydrogen. It carries 1/4 of a ton, so it's a very different and expensive. So that has been a challenge. Work package with Pilkington Glass, or NSG as the parent company is known. So we are planning to put hydrogen into one of that's operating at St Helens. We've got our work package 4 and 5, which is the boiler program, whereby our live site is Unilever's site at Port Sunlight, where they manufacture personal care products. We're also, as part of that work package, running a trial element to demonstrate that and give to their boiler. So at Dunphy Combustion, at their test centre in Rochdale, we're running a sort of short trial on a smaller boiler with a very similar burner. We'll be supplying the new burner for hydrogen. It allows Unilever and others to kick the tires, and that works. It's not going to cause any issues at Port Sunlight. Final work package is at SR at Stanlow Refinery. So we are. It's not a practical demonstration, but we are undertaking a front-end engineering design study for putting a replacement new gas turbine CHP system into the refinery that will run on up to 100% hydrogen. So the plan with that element is to get us to the stage where SR can get to a final investment decision following that FEED study and consenting, working with the OEM concerned with that project. I should say at the other sites as well, the objective is to enable in principle a final investment decision to be made as soon as hydrogen is available. So just talk about the scope. Sorry, lots of words on here, I'm afraid, but the scope of the three work packages in a bit more detail. So the Dunphy trial under the boiler package. So we are at Dunphy putting in a new tri-fuel burner at that. So that's a gas, oil, natural gas, and hydrogen burner, and onto the existing boiler. It potentially may need something called FGR, flue gas recirculation, to help manage the NOx. It's being installed to a 1 megawatt thermal boiler. We've got it says 2-week test program words. It's actually a 3-week test program, as you can see with the subsequent bullets. We're usual sort of thing. We're sort of commissioning and demonstrating sort of ramping up of hydrogen in stages incrementally over the first week. Then we'll be load following at 100% hydrogen for the subsequent week. And then we'll be week 3. We've actually integrated a sort of test program element for the HyDeploy project into this program as well, because obviously the main thrust of HyDeploy has been to demonstrate that the blend, up to 20% blend of hydrogen, can be supplied to buildings, to residential and commercial properties. Obviously, if we start putting 20% hydrogen into the 7-bar network and below, then quite a lot of industry is on the 7-bar network and below, surprising amount actually. So we actually need to show that industry can take that blend as well, as well as up at higher amounts of hydrogen, and it can do for a sustained period of time. So we'll be doing that at all 3 sites. So that trial at Dumfries should be taking place, we hope, by the end of this year. It may go into next year, depending on the issues associated with hydrogen supply. The Unilever demonstration, it's a 7 megawatt thermal package boiler, as I said, a ubiquitous boiler that, if we demonstrate at Unilever, that a vast majority of boilers in the UK can be converted. It's a 6-week test program, similar sort of approach in week 1, where we're sort of demonstrating on increasing levels of hydrogen, ramping up and down. Then we've got 4 weeks, weeks 2 to 5, sort of load following at 100% hydrogen to give us a decent sort of stack of data associated with the demonstration. I should say, I mean, I think the presentation was talking, running for maybe a year on hydrogen, etc. We had to sort of cut our cloth on this program according to the budget available. I think our 5.3 million budget was about a third of BEI's total budget for this program. And as I said, getting enough hydrogen has also been a challenge. So I think in terms of length of time, I don't think, I mean, we probably it may have been useful to go for a bit longer, but I don't think if we manage to run for 4 weeks, for example, at Unilever on 100% hydrogen, I don't think it would make any difference if we were running for sort of several months in particular. And then, yeah, week 6, we're obviously doing the HyDeploy trials, as I've said. That trial, we have had some impacts of COVID-19. It's been quite significant at some of the sites, so it's looking at being sort of probably late spring that we run that demonstration. I'm going to zip through this. I'm sort of conscious of time and need to catch up. Work package 4 at Pilkington, so that's at their Greengate Works site. What's called their UK5 furnace, 50 megawatt thermal furnace. We're not firing in all ports of that, but we're firing at a port that will be representative, or ports that will be representative of the whole, or certainly half the furnace. That again, coming back would enable Pilkington to make an investment decision to convert to hydrogen, a significant part of the furnace to hydrogen as soon as it was available. I should have said earlier, actually, with the HyNet project, we are talking about new hydrogen pipelines. We're not talking about doing away with the existing gas distribution network. So sites will be able to maintain that existing natural gas connection, and therefore convert incrementally, certainly direct firing sites like glass furnaces, brick kilns, etc. It is going to be an incremental conversion rather than a sort of switch on, switch off, 0 to 100% conversion. So we've got a similar test program. I won't run through that in too detail, but it's a 4-week program, again, sort of running at different levels of hydrogen and ramping up and down. And again, we've got a HyDeploy test there where we'll be putting hydrogen into all ports at a 50 to 20% blend. And that trial again is likely to take place in probably late spring. I talked about the SRCHP feed study. Again, as I said, we're replacing the existing CHP system. The feed is due for completion in March 21, and as I said, with the goal of supporting FID. It's one of my key messages. I think our experience as industry, and in particular direct firing sites, see hydrogen as the only real option for deep decarbonisation. I think they've done a lot of the low-hanging fruit around energy efficiency and electrification. I'll say that's all been done, but I think to get us, set us on the path to net zero in 2050, we really need to start looking at these sort of deep decarbonisation measures. Sites are ready to participate in demonstrations, but I think our experience is they usually need a sort of coordinating entity to sort of bid and manage the program. Everyone on sites usually have their day job, and they're not so motivated to actually get involved with the program, particularly if the funding intensity, the support is low, as is the case on some other program. This one is what's termed a pre-commercial procurement, and BEIS is 100% funding us. Other programs like IETF, which is out there at the moment, where you perhaps only get 30% funding and it has to be led by industry, it's far more challenging to get projects away. So with a fair wind, I think HyNet will be supplying hydrogen for real to industry from 2025, and that's why we're developing this evidence base now to enable us to convert our, the first sort of swathe of industry sites. And just to finish off, I think there have been some major challenges, and I would advise anyone, not that you can predict these things, but not to run a demonstration program in the midst of a pandemic, or with sort of likely impending national border restrictions, which can have an impact on your supply chain. So thank you for listening, and back to Nigel.
Yeah, thank you very much, Adam. That was extremely interesting. You highlight some of the challenges and the issues. Obviously, things like Brexit, COVID-19 are completely outside of your control. But in terms of your views of the barriers, you mentioned inadequate, what I think was inadequate supply of hydrogen.
Yeah.
What is the wider market assessment that you've done? First of all, around the Northwest, but also around scalability and how we would need to sustain markets on both the production side and the demand side.
Well, I think, yeah, that's interesting question. Yeah, I mean, clearly there have been challenges in supply, and there's limited sort of spare hydrogen around from the sites where it's produced for demonstrations. I think on production, it's an interesting question. I mean, and coming back to the point I made about maintaining the existing gas connection. I think in the future, conversion of gas networks to full hydrogen is a good and laudable goal. But I think in the short term, we have to have network resilience for hydrogen. Our first hydrogen production plant as I said, will be at Stanlow. It's a 3 terawatt hour per annum plant. But there will be one plant. We will be scaling that up, and we've got a big extension program associated with the project where we'll be building additional trains at Stanlow. We'll be building additional production plant at other locations in the Northwest to give us that network resilience. But in the first instance, it will be a new plant. There will be commissioning issues, I'm sure, associated with production, and that is why all industry sites, and the whole domestic network will be able to continue to run on natural gas should there be any supply issues over time. But we do have we'll be publishing a sort of update, sort of vision report in the next couple of weeks, setting out what our 2030 vision is, and how that looks in terms of what we aim to produce, which is about 30 terawatt hours of hydrogen, to give us a sort of material contribution to sort of the fourth and fifth carbon budgets.
Okay, and for those of us who are information junkies and get rather frustrated waiting for set piece reports that BEIS produce, how do we track the project and find out about your learnings?
From the fuel switching program, we have got a sort of knowledge dissemination function. We are going to start running. We hope to welcome industry to come and actually kick the tires and look at be present on the sites while they're running on hydrogen. and we as part of our contract with BEIS, we are we're obligated and very happy to share data from the program. So we will be disseminating that in due course. At the moment, because we haven't actually started running those demos yet, there's not a great deal to share, but we certainly will do in due course.
Okay, well, that was clear and quite illuminating. Thank you very much, Adam, and hope to catch up soon.
Thank you.
We're now going to move over to James Thomas. Morning, James.
Hi there. Morning, Nigel.
And you're data science lead at Kiwa, and you're going to be talking about balancing supply and demand in a hydrogen system. So if you could just introduce yourself properly and then take us through your presentation in 15 to 20 minutes, that would be great.
Sure. Can you see my slides?
Yeah.
Great. Well, thanks very much. My name's James Thomas, and I'm data science lead at Kiwa. A little bit more on who we are and what we do a bit later on, but just to introduce what I'm talking about today, it's matching supply and demand in an integrated low carbon energy system. That's a very grand title, but essentially it means designing a system that suits the local area, choosing the right mix of technologies and getting the best out of those technologies. And what I want to take you through now is that process for a couple of real projects. Before we start, I'd just like to take a moment to look at the picture I've got on the first slide. I think it's quite apt. Many of the initial hydrogen demonstration projects currently in the design stage are using renewable sources of energy, such as wind or solar, to generate hydrogen through electrolysis. But one of the challenges that many projects face is how to store energy in periods of high generation and low demand, so that in periods of high demand and low generation, they have some energy to access. So just like the nighttime in this picture here. So back to the talk, I've deliberately pitched it for a wide range of audiences. So there are some bits at the beginning you're very likely to be familiar with, and then hopefully some other bits as we go through that you might not have heard much about. So please bear with me. So as I'm sure many members of the public hopefully will now know, the UK is committed to net zero emissions of greenhouse gases by 2050. But perhaps what fewer people know is that other areas such as devolved administrations and city regions have committed to even tighter timeframes. So London is stuck with 2050, Scotland is 2045, Manchester 2038, and Birmingham has set quite an optimistic target of 2030, although there is a little bit of an asterisk there. They are allowing themselves to include offsetting to reduce their emissions. So just a little bit of background. Much of the planning for decarbonisation projects, which route you take, relies on measuring your current performance against historical benchmarks. So I always like to look at to see how we've done so far in the UK. And well, we've reduced our greenhouse gas emissions to a little over half of what they were in 1990. So currently about 56%, which is great news. Except the progress we've made so far has been much of the low-hanging fruit, or the easy wins. So, for example, since 2005, all new central heating boilers had to be the higher efficiency condensing models. For electricity generation, we've almost switched off our reliance on coal completely, and we use either renewables, nuclear, or where possible. And if we need to use gas, we use combined cycle gas turbines, which are more efficient and produce fewer pollutants than coal. And there's a tweet here that I found from earlier in the year where we had a period of nearly 68 days without burning any coal at all to generate electricity, which is a great achievement. Although I took a look yesterday and we weren't quite doing as well, so we had to turn it back on again. And also the efficiency of many industrial processes has been driven up by schemes like the EU's emissions trading scheme, incentivizing people to reduce their emissions. However, another impact this has had is that some industry has moved abroad and isn't captured any longer in our statistics. So the challenge we have is continuing this trajectory, even though the gains are going to get harder and harder, and meeting net zero by 2050, or as I say, possibly one of these nearer targets as well. And this means we need systems that allow us to decarbonize across all sectors rather than just one. So what are the sectors that we should target now for a first of a kind demonstration project? Well, the two largest end uses of energy, heat and transport, you can see on the graph there. On the left-hand side, 2/3 of that heating demand is currently provided by natural gas. Over 3/4 of the domestic block, which is the dark blue section, is also provided by gas. So at Kiwa, we've recently been working with customers on the specific question, what can be done to decarbonise both heat and transport? Can projects address both of them at the same time? And what benefits might looking at the two things together have? So looking at how this decarbonisation might be realised, the two main routes are electrification using heat pumps, battery electric vehicles, electrified train networks, etc., and continuing to use a gaseous or liquid fuel, but by decarbonising it. Now, I know I'm dwelling on this issue just for a little bit, but I think it's important to emphasise this isn't a hydrogen versus electrification battle. The two main routes have their own advantages and disadvantages, and both shine in certain areas. So at the risk of being a bit unpopular in a hydrogen webinar series, I'm going to say if electrification is possible, then I think you should strongly consider that as an option. But we shall see there are a number of situations where doing so would be a difficult fit. There's also biomass as an option for heating, and that's been supported in the UK through various renewable heat incentive schemes. But this can bring with it issues of poor performance and pollution, so it has to be used carefully. So much so that we were contracted by BEIS to conduct a field trial of biomass performance in the real world back in 2016. So the projects I'm going to look at now use 100% hydrogen to decarbonise the fuel, and that hydrogen can be produced from reforming methane or through electrolysis using green electricity. But as we've heard earlier in the panel discussions, as an alternative, you could do blending up to 20% hydrogen as well in the existing network. And finally, not forgetting that reforming methane produces CO2, so you need to do some form of CCS, carbon capture and storage, to prevent the final release of that CO2. And biogas or biomethane also play their part, but on their own won't be able to satisfy all of the UK's energy demand. So moving on to the actual projects, first let's focus on heat. The main feature that you see, if you look at heating demand, is a huge interseasonal variation. Looking here at domestic gas demand, and remember nearly all of this goes towards heating, we can see that in the winter it's around 4 times higher, at about 120 terawatt hours per quarter, it's the red line on the graph, than in the summer when it's approximately only 30 terawatt hours per quarter. So you can see these huge swings, and you see a similar seasonal variation in electricity demand in blue, but this is really dwarfed by the type of variations you see in the gas. Picking a couple of days in more detail and looking at daily demand, we can see there's also intraday variation, most noticeably in the winter. So with natural gas, this is currently handled with line pack by adjusting the pressure of the higher pressure tiers of the network, so transmission mainly. But designing an energy system that can cope with these swings in demand usually means having to utilize some form of large-scale interseasonal storage, possibly a smaller intraday store. And then what you would usually aim to do is run your hydrogen production somewhere between the two extremes. So if you take, for example, the dotted red line on the left, this allows the production facility to operate at near 100% utilization for most of the year, which usually gives you the best performance of the systems that you use. But an interseasonal store like this is a big storage requirement and usually means investigating geological storage options such as salt caverns, we mentioned earlier, aquifers or depleted oil and gas reservoirs. And indeed, this is what was considered in the H21 Leeds Citygate project, which looked at using a 700 gigawatt hour store for about 660,000 people in Leeds. But we're not at that scale, we're a small scale demonstration project, so this is far too large a scale and we have to consider some alternatives, so more on these shortly. Thinking now about how we generate the hydrogen, first let's look at using renewable wind energy. The UK has about 24 gigawatts of wind generating capacity currently, both on and offshore, so there's a map showing the locations of the sites here. That places it about 6th in the world and about 3rd in Europe in terms of capacity. But the wind is intermittent and very variable on the order of minutes sometimes. So I've got a graph here for January 2019. So it was quite a cold period of time. And you can see, if we go along the bottom on the x-axis, there's the days of the month, and we can see around kind of the 7th of January, it can be almost nothing one day, and then say 15 gigawatts on average the next day. So this highlights that using wind power as a source of energy in a system, the system must be able to cope with peaks and troughs in wind. And generally, you either do this by being able to turn the production systems up and down very quickly, and you have some kind of short-term storage to fill in the gaps if you've still got demand, but the wind has stopped. Or alternatively, you design a system where you're able to switch to the electricity grid as a temporary source of energy if the wind drops very, very quickly and your system, your generation isn't able to slow down quickly enough. So I think that brings up an important question, which is what is the purpose of storage in your system, and what is your storage strategy? So we've already talked about the fact that you might have an interseasonal demand that you might have to cope with. You might have differences in demand within the day, so intraday demand. You might have an intermittent source of generation, but also you might have various constraints around security of supply. So sometimes you might have to guarantee that you can always supply a certain period of heating, say if you're providing energy to domestic homes. So whichever of these your storage is aimed at, that will define the design of your system and the sizing of the components in the system. It may be one or more of these. So it's really important to understand this from the outset. So as I promised now, to give you some context, let's look at a demonstration project using renewable wind, although equally it could have used solar PV. Got a picture there. And what I'm going to talk through is very indicative of SGN's H105 project, where Kiwa carried out modelling work as part of the feasibility study. So the public report is now available on gov.uk. However, I'm going to give you a little bit more detail into the methodology for the modelling here. So renewable energy is used from wind to power an electrolyser to produce hydrogen from water. The hydrogen is then stored before being distributed through a purpose-built distribution network to local homes. Storage is in the form of compressed gas tanks or bullets. They're sort of these horizontal tanks that you see here. Now, these are expensive for the capacity of storage that they provide, but they're available at a small scale. And in this case, the purpose of the storage was primarily to manage intermittent generation. So if you recall that graph of the intermittent wind generation. And also, we had to provide security of supply because we were supplying domestic properties. We had to guarantee a certain amount of supply in case of equipment failure. We're not providing interseasonal storage here. And so we had to make sure that the electrolyser was sized so that it was able to provide peak demand in winter. Now, this isn't necessarily the most cost-effective thing to do in a large system, but for a small first-of-a-kind trial such as this, that's generally considered the safest thing to do. So if the storage starts to get a bit low and the wind hasn't picked up, then we need to have a backup source of energy. And so we use the electricity grid to top up the store with some more hydrogen. But so doing this is very expensive, and it's something that you need to avoid if at all possible. But on the other hand, if the store is full and it's still windy, then what can we do with this extra energy? Well, we could generate additional hydrogen and maybe blend it into the local natural gas grid. But for a project like this, that adds an additional layer of complexity. And so we have to choose, in this example, we just chose to export that excess electricity back to the grid. So the question in this case that we answered was, how do you minimize the storage requirement and maximize the use of renewable energy whilst meeting the minimum security of supply requirements? And the process we followed was we used actual wind, temperature, and demand data to make a dynamic model of the system with different levels of storage. We looked at 5 candidate electrolyser models, each of them having different response times, different efficiency curves, and we ran these through the model. And we also stress tested each scenario of each final design using 1 in 20-year extreme weather events. And that was really to ensure that the system provided this security of supply and it wouldn't fall over in, say, a particularly cold winter if there was low wind. And then the successful designs were then presented and costed in the output of the feasibility study. And just for the technical among you, just to note, there's many sort of engineering steps that I've omitted from this picture here. So you've got things like compression of hydrogen before storage, odorization of hydrogen after the storage, pressure let down before the local distribution, etc., etc. So as the project was taking electricity, converting it to hydrogen, and then selling it at the same price as natural gas would be sold at, it was crucial to avoid purchasing expensive electricity from the grid whenever possible. So here's a sketch of the kind of results we obtained from our modeling. And what you find is as you install additional storage, so that's moving from left to right on the x-axis, you increase your capital expenditure because you've got to buy the storage at the beginning. But it also means you're less likely to need to import grid electricity because your storage is less likely to start running low. So that means that your operating expenditure goes down. So then if you put the numbers in, we find that there's a trade-off between paying for grid import when the wind is low, and then paying for additional storage to avoid that grid import. And it's possible to find this kind of sweet spot on the green line there where it's lowest, and you get the lowest levelized cost of energy by balancing all of these. But it's not just a sort of blueprint you can apply across the board. All of this depends on the response rate of the electrolyzer that you're looking at, how much it can turn down its output. The technology you choose also impacts the sort of the cost and the maintenance requirements. The rate of change of the intermittent generation that you're using has an impact. And also there's other constraints on storage often. So as I've already mentioned, there's a minimum storage requirement often to ensure security of supply. So I spoke earlier about transport as well. So let's have a little look at that. In a similar vein to what I said at the start of this talk, there are applications that are suited to battery vehicles, and there are other applications that are suited to hydrogen fuel cell vehicles. Having a look at some of the reasons why you might choose one or the other, and let's take trains on the left-hand side as an example. If you can electrify a train route, then you probably should do so. But the problem is not all train routes can be electrified. Sometimes there are obstructions in the way, tunnels, low bridges that require a lot of effort in order to electrify, or maybe there just aren't that many trains on that route, so it's not cost effective to put the infrastructure in. Buses on the right hand side, often in rural areas, you have quite long hilly bus routes with long distances between the stops and back to the depot. And then also you have the problem of timings for refueling. So often these systems operate without many spare trains or buses because you want to optimize your asset by keeping them running as much time as possible. So there aren't often long periods of time you can use for refueling the vehicles. So usually it's done at night. So you have to make sure that they have enough range in order to get back at the end of the day. But as you know, we live in the real world, and you know, what about delays and cancellations? So trains, for example, might not be where you want them to be at the end of the day. If there's severe delays, they might be left stranded at different parts of the train network, and you've got to have a system that's flexible enough to cope with this. Just another point that's of note, if we're talking about potentially using hydrogen, then the vehicles here that use hydrogen fuel cells, they may all have slightly different purity requirements. So whereas a car may need particularly pure hydrogen, you might find that in a bus or a train, depending on the sort of the model that the manufacturer operates to, you may find you could use a slightly less pure form of hydrogen and maybe replace the replace the fuel cell more frequently, and that might be acceptable. So just taking a quick look at the different transport applications that you could potentially convert or decarbonize. I've got a sort of schematic here of different types of transport, but splitting them out by the distance they tend to travel in a day or in a particular journey, and then how heavy they are and how much they transport. So at the bottom left, we've got scooters, small cars, things that usually happen within cities, and these are definitely suited to battery electric. Then as you move up towards the top right, we've got light commercial vans, fleet vehicles. These are kind of right on the edge of, you know, they could run evenly well with battery electric or fuel cell electric drivetrains. If we keep moving up, we've got freight and buses, and then moving up again, we've got trains. Now these are kind of really well suited to hydrogen fuel cell electric. And then if we move right to the top right, we've got shipping and aviation. And these are probably better suited to some kind of direct firing. So it may be hydrogen or some other kind of green fuel. So we're going to focus on these ones in the center, the ones that are suitable for fuel cell electric. And as promised, here's another demonstration project just to give some context. This is a project we're currently working on that's designing and assessing the feasibility of a hydrogen system that provides both transport and heat. So the area of interest currently has little in the way of wind and solar resources. So in this case, we chose to utilize natural gas and reforming to generate hydrogen. And specifically, we're using a steam methane reformer in this project. This means that we have a stable supply of energy from the natural gas network. So the storage that we have here is primarily to provide intraday storage and security of supply. We're providing the hydrogen to local buses and also heat networks. Again, for this demonstration project, that'll be through a purpose-built low-pressure network, so we don't have to worry about picking up contaminants from the grid. Now, as we're supplying heat networks rather than domestic properties, the demand profile will be a little bit different, but for simplicity, I'll assume it's roughly the same here. Don't forget the CO2 though, because as I say, we're doing reforming, so we need to capture and store the CO2 somehow. And we're currently applying the same modeling process here as I described earlier, So why does combining demands affect the storage requirement? And why might we be able to do away with interseasonal storage? If we're supplying the heat network alone, with its interseasonal variation, that's represented by the bars on the left-hand side, then it's impractical and not cost-effective to size the hydrogen generation for peak demand. If we did so, the plant would probably need to be about twice as big as the average daily demand, and it would need to be able to turn down to only 25% output during the summer, which, if we're using an SMR to reform methane, this is going to be very difficult to do. However, when we include the transport system as well, in this case, the bus network, this provides a more or less constant baseload year-round, represented by the bars on the right-hand side. So we'll still have the same absolute difference between the summer and the winter, but the relative difference is much smaller. This means the peak demand is now only 20% bigger than the average daily demand, and the plant only needs to be able to turn down to 67% of the maximum output. And this is much easier for the plant to do. It means you're not paying too much and not paying for, much more plant than you would need. So where are we? This modeling work is still ongoing, so I can't present the full results of it yet. However, one thing that I can show you is that there is a bit of a happy coincidence when it comes to intraday demand. So if we take this sort of chart here and imagine it's a kind of a 24-hour clock, the transport demand occurs during the night time when they refuel the vehicles, and that's often at night, finishes by about 6 a.m. This is, however, precisely when the heat demand is generally the lowest. Then in the morning from 6 a.m. till about 9 a.m., this is for the sort of first morning peak in domestic demand for heat. When this drops away, you tend to find the demand commercially for heat will pick up when people go to offices. And then when people go home at the end of the day, this is again when the domestic demand picks up before dropping off, and then again the transport demand takes over. So this isn't the reason why we combine the demands, but it is a kind of a nice side effect that you get. So that was a high-level introduction with a sprinkling of detail here and there, but I hope I've shown you there's quite a lot of thought that goes into designing and testing a potential system. Really, the take-home messages are hydrogen is giving you this additional route for decarbonisation other than electrification, and the real advantage, as we've heard from the other speakers, is the longer-term storage that you can have. But what we found is the design of these first few systems is sort of heavily affected by the specific local resources, demands and funding that you have. You have to consider the performance of all the components in the system and also think about what's the purpose of the storage and think about those 4 blocks that I showed earlier. And then finally, you've got to dynamically model the system. So you can't just use annual or monthly totals and say, yeah, it looks like it'll work. You really need to consider it on a sort of a minute by minute basis and say, based on the rates of change and how the technology can respond, will the system work? And then once you've done that, you've got to test worst case scenarios to make sure that you would have security of supply in the case of maybe a cold winter. And finally, as promised, just a word on Kiwa and what we do. we've got offices worldwide and particularly across Europe. Primarily, we're a testing, inspection, certification company with expertise in many low carbon systems, hydrogen, heat pumps and biomass. We also offer training in low carbon technologies, including biomass and hydrogen. And we have an online course called Hydrogen in a Natural Gas Network that's accredited by IGEM, split over 2 days, currently being delivered on Teams or Zoom, given the current pandemic situation. But we also offer consultancy, and I'd just like to finish by saying what I really like about projects like the two that I've talked about today is that they bring together my engineering colleagues on the kind of hydrogen services side of the business. They have a knowledge of the production plant and the systems, the hydrogen components and gas safety, with my energy analytics team on the other side of the business with our demand and generation modeling expertise. And we're using those two teams of people together to kind of work on a project like this. And that's what I think makes it so interesting. So that's me. Thanks very much for listening, and thanks very much. Back to you, Nigel.
Yeah, thank you very much, James. That was absolutely fascinating, and interestingly enough, one of the themes we're trying to develop with Hydrogen East in an area which is very low on industrial loads, large loads, is exactly this type of diversity and linking different process uses and trying to understand the interactions with transport. So this is absolutely on the money, and I'd like to pick that up with you at a later stage.
Sure.
So really what this does is give you a user, once you've perfected the technique, of working out which technologies work best for them. Obviously, electrolyzers are an important component within the production process here. At what point do you think the economics start tilting for the wider scale use of green hydrogen?
That's a really good question. I think at the moment, I think it's really interesting hearing earlier today about the plans that the gas networks and the industry have for sort of the longer term planning. But yeah, what we also need are these first few projects, and it's a little bit sort of chicken and egg at the moment, in the sense that we have a potential demand for hydrogen, but especially in the transport sector, there you'll find it difficult to promote that demand if you don't have any supply of hydrogen that people can rely upon. So exactly what these particular projects at the moment are aimed at is you're trying to kind of accelerate that by providing a bit of stability by having a few different demands, and then hopefully kick-starting that process. So I think we're definitely in this kind of these first few demonstration projects at the moment, and I think when those kind of pick up and demonstrate that this is possible and it works, what we're looking at is then the kind of the national picture, of the sort of distribution of hydrogen catching up a bit. I think it'll be then that hopefully we're designing these systems so they can kind of plug in then and then access and expand. So it's not just a project that in isolation, there's also some sort of expansion planned into it. So I think we're not quite there yet, sort of, but I think once we kind of demonstrate at a local level that these hubs work, then once we get a number of hubs in one area or wider distribution from the gas networks, then certainly they can then start plugging into each other, and then I think the expansion would become a lot easier.
So it's kind of mix and match, really.
Yeah, for the time being.
Lovely. Well, thank you very much indeed, James. That was fascinating. We're going to hand over now to Thomas Kohler, who is I don't know, I'm looking at my notes. I know exactly what Thomas does. He's the Gas Goes Green lead at the Energy Networks Association, and he's going to talk about the transformative plan that is being developed by the network companies. Over to you, Thomas. Let's make a start.
Great. Well, morning, everybody. And pleased to be able to join you today, and it's been great hearing from all the super speakers we've been having and the excellent chairing, Nigel, that you've been doing. So I'm Tom Collar, the Programme Lead for Gas Goes Green at Energy Networks Association. What I'd like to cover today is a bit of an introduction to Gas Goes Green, take you through our pathway to net zero, and then focus on our hydrogen transformation plan, a key output for Gas Goes Green that we have coming up over the next few weeks, which will really look to understand how we deliver the hydrogen transition and what that means for different gas consumers, and that our plan is indeed practical and deliverable. So for those of you less familiar with Gas Goes Green, it is a joint initiative between Energy Networks Association, National Grid, Cadent, who you both heard from earlier, as well as Northern Gas Networks, SGN, and Wales and West Utilities. It has the aim of delivering the world's first zero carbon gas grid, helping meet the UK's net zero greenhouse gas emissions targets. And we formed the programme really to build on the work done to date by the gas networks in relation to decarbonisation. So their support for biomethane plants, we now have more than 100 of those connected to the gas networks, including one on the transmission network, as well as the network's work on hydrogen blending, which was discussed earlier today, and their plans for developing 100% hydrogen networks. And we wanted Gas Goes Green to really bring together these different focuses of gas networks and the work that's done to date, and have an integrated and singular plan for how we move forward. So the shared programme really provides this means of coordinating network activity and provides a way of taking forward new collaborative work. Now, since Gas Goes Green launched in April this year, we've been busy, it's fair to say. Our work sits across 6 different work streams. We have work streams on investing in net zero, on gas quality and safety, on consumer options, on system enhancement, and on hydrogen transformation. And in terms of our recent work, Danielle Stewart from National Grid mentioned this morning. We published in May our zero carbon commitment, which sets out the investment we see as being required over the next 5 years to deliver the network projects needed to demonstrate the safety case and deliver evidence through live trials. Also in May, we published our hydrogen cost to consumer report, which really models the benefits of early investment in hydrogen. We've also held some webinars recently. The first of these, you can see on the screen there, supported iGEM's consultation on changes to gas safety management regulations. And there was a second workshop that we ran in July on hydrogen deblending. In terms of what we have coming up, so I'll talk a bit more about the hydrogen transformation plan. We also have some guides that we will be producing and publishing shortly on conveying the shared network pathway that we have. We'll also be building on the pathways to net zero work that I mentioned that had formed the programme, really to check and update some of the assumptions that went into that work, and to see if we have any updates to report on that basis. We also want to sort of unpack or add the next level of detail down from that high level pathway to understand what the profile is of biomethane or hydrogen volumes between now and 2050, and what might that mean for different heat technologies or heating appliances that are required along the pathway, just how many heat pumps are required at certain points, or hydrogen ready boilers are required at certain points along the way. And you can see some of the other deliverables we have planned for the year here too. So hopefully that's given you a taste of Gas Goes Green and what the UK gas networks are collaboratively working on.
Thomas, your slides don't seem to be moving along the carousel.
Okay.
Yay.
They do now, okay.
Yeah, excellent, thank you.
So I'll just leave them on this view, hopefully people can still see. So I've mentioned the Pathways to Net Zero report a couple of times, and this really provides the foundation for the Gas Goes Green programme. The report, published at the end of last year, puts forward two different scenarios. And both of these cover buildings, transport, power and industry sectors, and both meet net zero. The balanced scenario is one where low carbon and renewable gases are used in combination with increased electrification. And I think this aligns with the point James was making in his presentation just a few minutes ago about the need really for both electrification and gas to play a role. And our balanced scenario also requires huge strides to be taken in energy efficiency and adoption and rollout of CCS. So that's the balanced scenario. And then we also have a high electrification scenario where molecules, low carbon gases are really used where there's no alternative and that actual molecule is being required. So the report that we have describes the 6 stages in detail, and you can see the 6 steps on the pathway set across the top of this chart. And on the chart itself, you can see the changing gas composition out to 2050, a gradual decline in the natural gas provided to end users, and an increase in hydrogen and biomethane. In step 1 of our pathway, this is really about preparing for the transition. So we need to progress with the changes to gas safety, gas quality regulations to enable the injection of low carbon and renewable gases, a wider set of gases. We also need some policy to be put in place to support later changes in the pathway. So the first of these would be mandating hydrogen-ready boilers, but also changes and policy to take forward and support CCS. And positive to see the government's recent response to the business models consultation. If part 1 is all about preparing for the transition, the next stage is to facilitate more connections. So for us as networks, we see the first the role here really to standardize the connection regime to enable more biomethane plants initially to connect to the gas networks. So we want to simplify the connection regime, speed it up where possible, and ultimately reduce costs where possible as well. And although that's a change that will impact biomethane plants in the immediate term, that will also then provide a new foundation, a new connection regime for distributed green hydrogen production as well. It's at this point, this is step 2 of the pathway, where we would be finalizing preparations for the first hydrogen projects. So we have a trial in development on hydrogen on a new network, H105, that SGN are leading on, and another trial on repurposed networks as part of H21 that NGN are leading on. And we'd also be seeing the significant ramp up in energy efficiency improvements during this second step of the pathway. Step 3 is then all about expanding supply. So AD deployment ratchets up, and there's development of thermal gasification technologies. And then step 4 of the pathway, after we've expanded supplies, is to expand the demand base. So here we see these hydrogen clusters developing with anchor customers in industry and in transport. And outside of the clusters, customers are receiving an increased amount of biomethane in place of methane in their supply. In step 5 of the pathway, the clusters that have emerged merge to form hydrogen zones. And at this point, the NTS is reconfigured to transport hydrogen to and between clusters. And again, outside of those clusters, there are biomethane zones elsewhere. So what we arrive at by step 6, close to 2050, is a net zero energy system where natural gas is only used for production of hydrogen with CCS. The resultant gas supply is a highly regionalized one with hydrogen zones and clusters in some areas of the country and biomethane zones elsewhere. So that's our vision for 2050. And you can see from this chart the volumes of hydrogen that we are expecting in 2050. So 236 terawatt hours of hydrogen, and is split there between blue and green. One other chart, actually from a different report that I wanted to share with you. So this is from our cost to consumer work that I mentioned, a report from May this year. And this report has a larger volume of hydrogen figuring in it, and indeed a higher proportion of green hydrogen in there. So with this, in this report, we see the first blue hydrogen capacity being built out to meet the first CCUS projects being commissioned in 2025, in line with government objectives there, and production volumes of 92 terawatt hours per annum continuing out to 2040, when they then increase, growing to 335 terawatt hours in 2050. What we would see is, due to limited excess renewable generation and high capex costs initially, that growth of green hydrogen from electrolyzers is relatively slow. But that as the level of excess renewable generation grows and electrolyzer costs come down, then this the share of green would increase up to 2050. So I wanted to give those two perspectives there of the crucial role we see hydrogen as having in the future of the gas networks in terms of what's supplied and transported through it. The final aspect I want to focus on today is our hydrogen transformation plan that we're working on for publication in October, which sets out how we will deliver the vision I've just been describing and what this means for different gas users. So the report will have chapters on different gas consumer groups, and there are important considerations and questions for each. But as our focus for today is industry and homes, I'll focus there. On industry, as I've discussed, our pathway really takes shape as industrial clusters develop. But we don't want to forget about non-clustered industry. And there are questions we need to think about in terms of how their heat and power requirements are best met, but also about how their carbon would be transported and stored. So we want to be tackling these questions in our transformation plan to ensure that the whole transformation we're envisaging is deliverable and is practical. And for households, we've been working very closely with boiler manufacturers to understand when they could bring hydrogen-ready boilers to market, but also to understand what the cost differential would be relative to current boilers. So we can then tackle questions like whether we can justify hydrogen-ready boilers being rolled out across the country, even to areas which might not have a subsequent conversion to hydrogen, where those users might end up just switching from methane to biomethane, for example. So these sorts of questions and others impact how the transition will take place. And the gas networks have significant work underway to build the evidence required in order to be prepared for a variety of different network configurations and for the different volumes of gas being transported at different times out to 2050 and beyond. So that's just a taste of our forthcoming hydrogen transformation plan, and the document, the report that we'll be launching in October will provide a lot more information on that, and I look forward to speaking with many of you further on that when we launch the report and get stuck into it further. But for now, I'll pass back to the chair.
Thank you very much indeed. That was very interesting, hearing about the pathways to net zero and your transformation plan. Is the October document a kind of framework, a consultation, or will it contain specific proposals? And then looking forward, what do you envisage to be the next 2 or 3 key stages in the work programme?
So the document we're putting forward in October is the result of a lot of stakeholder engagement we've been doing over the last couple of months, and we've run some workshops to draw in a lot of different views and to really test and interrogate network views on things, and to see where and why views networks might have might not align with views industry or domestic groups might have. So it provides a really good opportunity and milestone publication for assessing and comparing different options and judging where we are as an industry in terms of being able to move forward. In terms of what comes next after that, I don't want to second guess the report too much, but I think what's clear is that we will need to investigate different options in more detail. And whilst the report will make a significant contribution, I think the networks would appreciate that we really need to get stuck into some complex modelling to begin to fully map and understand how, sort of almost by street to street, we would do a conversion and what the implications of that would be.
Okay, that's absolutely super. I've got loads of questions, but I know you're a little bit pressed for time. So thank you very much.
Thank you, Nigel.
I'd love to have a chat about some aspects of that at a later stage, please. But moving forward, that was the Gas Goes Green programme that the Energy Networks Association has been carrying out over the past 6 to 12 months. There's an awful lot of stuff around that, which is very well signposted on the ENA's website, and I do recommend people check that out. But our final speaker today is Rob Ireson, who's Innovation Manager at Glass Futures. He's going to talk us about, funnily enough, switching technologies in the gas sector. Rob, would you like to introduce yourself and then take us through your presentation, please?
Will do. Thanks. Thank you very much for inviting me to present today. So my name's Rob Ireson. I work for Glass Futures. I've been working for Glass Futures just since March, but before that I spent about 8 years working in R&D within the glass sector, and 8 years before that working in the R&D within the steel sector as well. So Glass Futures is a relatively new enterprise. So we represent the whole of the glass industry. So we've got members who are manufacturers. We represent the full supply chain within the glass sector, as well as academic partners, research organisations and trade associations. And our vision within Glass Futures is really to create a global centre of excellence for glass manufacturing. So we want to work with our members to really reduce the environmental impact of glass throughout the life cycle. So we're looking at developing new, more efficient manufacturing processes. We also want to look at reducing the environmental impact of glass throughout its use and also end of life through reuse and recycling. And then in addition to that, we realised that glass as a material has loads of really exciting potential. So we also want to look at ways of how we can drive developments to maximise functionality of glass, to maximise the value to end users and customers as well. So in terms of how we want to do this, we see Glass Futures as really bridging the gap between academia and small-scale research and industry and commercial production. And what we want to do is create a platform that can really accelerate developments through to commercialisation. Now, this is really important for the glass sector, because within the glass sector, most manufacturers might only have 1 or 2 furnaces on their site, and those furnaces could have a production capacity of up to 900 to 1,000 tonnes per day, and the furnaces are expected to operate often continuously for about 20 years. So that means it's a really risky business to trial new technologies on their production facilities that haven't been trialled before, because it just can't really afford any loss of production. So what we want to do within Glass Futures is to provide a platform on which technologies can be trialled at scale before then being transferred into commercial production. So we want to develop a 30-tonne per day mini glass manufacturing pilot line that will hopefully be built in St Helens in the UK. And the reason we've chosen 30 tonnes is because it's large enough to be industrially relevant, so we can upscale the results and translate them into commercial production. But it's also small enough to be flexible, so that we can try really new and exciting technologies in a way that's relatively cost effective and where we can manage the risk. It's also worth mentioning that this facility will be designed to run off hydrogen as a fuel. It's actually within the scope of the HyNTS project that Adam from Progressive Energy mentioned earlier. So hopefully we will have a supply whereby we can trial hydrogen technologies. And it's also worth mentioning that hopefully in the future we have plans to expand this facility further. So in phase 2, we're looking to develop a 150-tonne per day mini glass line that can also make flat glass as well. So we really can service all aspects of glass manufacture. There's just a little diagram of what hopefully the facility will look like. As I mentioned, it should be able to run off hydrogen fuels and should be commissioned in 2023. So in Glass Futures, we've engaged much of the glass sector and identified a number of key areas or key technology themes that we want to drive within the glass industry, which is shown here. And I think it's important to note that actually if we are going to switch from the current natural gas-fired technologies to hydrogen, actually we will have to look at all these different areas, because each one will be affected by changes in fuel, particularly things like new glass compositions, but also things like refractories and inspection technologies as well. Unsurprisingly, one of the key challenges that the glass industry is facing is the need to decarbonise our manufacturing processes. The UK glass industry alone produces around 2 million tonnes of CO2 per year, and about 80% of those emissions come from the glass melting process itself. And the majority of those come from the combustion of natural gas, which is the current technology that's employed in pretty much every glass furnace in the world today, other than a bit of electric melting. But effectively 80% of those CO2 emissions come from the melting process. So that's obviously one of our primary targets that we need to address if we're going to decarbonise the industry. So with this in mind, we are working closely with the industry and their decarbonisation roadmaps. We want to make sure that all of our developments are aligned with those current initiatives. And through this, or off the back of that, we were able to pull together a really great international consortium to try and work together to address this challenge of trying to decarbonise glass manufacturing. So the consortium we pulled together consists of over 20 partners, including manufacturers. It included a number of companies from the supply chain, particularly in terms of the furnace and combustion side of the supply chain. And then we also involved a whole range of research groups and partners as well, from academia, but also glass specialists, combustion specialists, as well as economic experts and trade associations as well. And we applied for a £7.1 million grant under the UK government industrial fuel switching scheme. So that's the same scheme that Progressive Energy mentioned earlier, that funded one of their projects. and pleased to say that we were successful in that. So the £7.1 million project started in January of this year. The aim of the project was really just to understand different fuel scenarios that could be used to decarbonise the glass melting process. So we actually came up with 4 different scenarios that we want to investigate in the project. We're looking at biofuels, we're looking at hydrogen, as well as full-scale electric melting, and then hybrid combinations of all 3 of those. So today, obviously, I'm going to be focusing on this work package for the hydrogen technologies. So within the project, we identified very quickly that it's really not straightforward to switch from natural gas for melting glass to using hydrogen. There are a whole host of challenges that we need to understand and then look to try and address. So first of all, in terms of technical challenges, we're just very conscious that the way in which hydrogen combusts is very different to that of natural gas. For example, there's higher combustion velocities, the flame can often burn a lot hotter, even things like the radiation that's emitted is very different. It can often emit more in the UV than the infrared. And all of these aspects of the combustion process will have a significant impact on the way in which the raw materials are melted, and then the glass itself is refined and processed. So we need to understand those differences, understand how to address those, and try and sort of modify the way in which the hydrogen is combusted so that it is compatible with glass manufacturing. We've also got other technical challenges, such as the higher moisture content of the combustion atmosphere that we get when combusting hydrogen versus natural gas. And that can have all sorts of impacts on the process. For example, it can increase the corrosion rates of refractories. It can also affect the glass itself. It can affect the glass chemistry, the way in which certain components might volatilize from the glass, includes things such as foaming inside the glass furnace, as well as maybe affecting the viscosity. So all these things need to be understood, and the aim of the project is to not only understand them, but actually work out ways of addressing them and getting around them so that we still get a really good quality glass products at the end of the process. Within the project, we're also looking at the economics. So it's important not just to look at the technical challenges. We need to understand how it fits into the economic landscape, which I'll touch on later. And health and safety is also something we need to understand. So hydrogen is a very different gas to natural gas. There's going to be different health and safety implications that we need to understand and address if the industry is to start switching and using hydrogen in its plants compared to natural gas. And then finally, we've got the environmental considerations. So we're also conscious that the switch will also lead to environmental challenges. For example, the higher flame temperature that we might expect to get with hydrogen could well lead to higher NOx emissions. So again, it's something that we confident we can address, but we just need to understand how best to address that. So those are the challenges. In terms of how we propose to address those challenges, within the project, we are undertaking a whole series of experiments, from computer modelling and simulation of furnaces, through to lab trials, through to industrial scale trials. So the first bit of equipment that we're developing is a 350 kilowatt combustion test bed. So the aim of this unit is to simulate the combustion conditions that we might expect to see in a furnace. So this is actually designed to be a scale model of a real glass furnace. It was originally designed to run off natural gas, but we're basically upgrading it so it can run off hydrogen or biofuels as well. And the aim of these trials is really to benchmark the different fuels against natural gas to see how they perform, how they compare, what the heating rates are like, for example. But also then the next stage is to then understand how we might optimize the combustion process, how we might change the burners, how we might change the gases inside the combustion chamber, so that we can really kind of get a combustion process that's as close as possible to that which is used or experienced in current glass furnaces. Another piece of equipment we're developing is a small glass melting furnace that can melt up to 100 kilograms of glass at a time. The name of these trials is to compare natural gas to hydrogen in terms of how it melts the raw materials, and then how it kind of refines the glass, how you get a nice kind of homogeneous glass composition, and how you get rid of things like the little bubbles in the glass to get a really good quality melt at the end. And It's likely that we will have to do some compositional changes to the glass as well in order for it to be compatible to using hydrogen as a fuel. So the aim of these trials is to start investigating some of those changes that we might have to implement as well. And then finally, we are also looking at how we might upscale the new fuel technologies onto a commercial plant. So we are in the process of undertaking some computer simulation and modelling trials of glass furnaces to see how different fuels might impact the furnace, how we might have to modify the furnace even to cope with the different fuels. We've got a commercial scale trial of biodiesel on a glass manufacturing plant lined up. And we're also undertaking an engineering study just to understand how we might convert a commercial glass manufacturing plant from natural gas to hydrogen. So that's really looking at the whole site, not just the furnace, but all of the other different parts of the process that currently use natural gas, how we might switch that over to hydrogen, and the engineering implications, the health and safety and the training implications that would need to be considered, and the costs involved in that. The name of this study is really to create a dossier of information so that glass plants can make an informed decision as to how they might conduct trials of hydrogen in the future. As I mentioned earlier, it's important not just to consider the technical challenges, we need to understand the economics as well. So within the project, we're working very closely with Element Energy to build a really detailed, in-depth economic model of the different fuel scenarios that we're looking at. We're looking at both the capex costs associated with switching from natural gas to other fuels, as well as what the opex might be as well. And the model also considers things like future predictions of fuel prices. The aim is that we're going to have by the end of the project, we'll have a really flexible model that we can input new data as it arrives, new forecasts, etc. And hopefully that will create a tool which will really help industry to make informed decisions as they make investments into the future. So I'll finish off just by setting out what the roadmap might look like in the conversion to hydrogen. So the fuel switching projects that are ongoing at the moment are due to finish by 2021. Hopefully by the end of those projects, we will have demonstrated that it is possible to use hydrogen in glass furnaces. Hopefully those trials will then continue into 22 and 23 once we get the pilot plant in St Helens up and running. And I think if the industry really gets together and if we really start to understand the challenges and really throw our weight behind trying to switch to hydrogen, I'm reasonably confident that as an industry, we can actually do our first 100% hydrogen trials on commercial glass plants by 2025. And then by 2030, as the volumes of hydrogen in the national network start to come online, I think there's a real chance we could possibly see the first commercial furnace running with 100% hydrogen 100% of the time, maybe as early as 2030 as well. So I think that finishes my presentation. In summary, I think it's safe to say the glass industry is really keen to decarbonise. We're confident that we can, and we're confident that hydrogen has a key role to play in that as a low carbon fuel option of the future. And although there's still a lot to do, we really have got a lot of expertise in the industry, and we're working with a lot of other partners across other sectors like progressive industry as well to learn from that knowledge. And hopefully, if we all work together, we can deliver this as a real option for the glass industry within the next 10 years. So thank you very much for listening, and welcome any questions.
Thank you very much, Rob. That was fascinating. I must admit, the glass sector is a sector I just kind of take for granted, like probably 99% of the population. Yet it's a very good example of a hard to reach sector, which has some very specific physical requirements. You mentioned earlier that 2 million tonnes of CO2, is that just in the Northwest connected with your scheme, or is that across the industry in the UK generally?
That's across the UK. So Glass Futures is we've got a global ambition. So obviously we're based in the UK, but we've got international partners as well. So many of the glass manufacturers we're working with are from around the world, have plants across the world. But the 2 million tonnes is just UK emissions. So from all the glass plants across the UK for the whole processes.
And just rewinding a little bit to Adam Badley's comments earlier, which was around I suppose it's a more conventional project. I know it's still innovation, but the technological challenges are fewer, and it's about deployment and scaling and connecting different bits which work in different ways. There are some very novel technical elements about your project, but your project as well as theirs are both under the fuel switching competition. Yep. How do the arrangements around that work to make sure that everybody's learning and also that there is dissemination of the learning?
Yeah, good question. I think it's just making sure we keep talking to each other and learning where we can from each other's activities. So Pilkington, who are part of the project being run by Progressive Energy, they're also involved in our project as well. So we've kind of got a number of partners that are on both projects. So that's an opportunity to share knowledge. And I think once we kind of progress with kind of future trials, I think again it's just making sure we can disseminate information as much as possible and allow that kind of cross-pollination of ideas and learning and knowledge wherever possible. So I mean, I think if anyone does have any questions or wants to pick things up offline, certainly very keen to talk to anyone out there.
Yeah, I think one of the things that struck me about today, and I guess I've been finding this increasingly, is there is so much going on in the hydrogen space, but you tend to have to know where to look to find it. And, you know, there is such a volume at the moment that it's important to be able to work out what you need to look at, really. Okay, well, it's absolutely super. And as you say, any questions, please direct them in. Where should I go to find out more about this particular project?
I am more than happy to set up a meeting to discuss it. We're now conscious we're still sort of in the earlier stages of the project.
Yeah.
The project's currently not due to finish till the end of next year. I think certainly once we start getting results from our various tests, we are looking to publicise those results. But in the meantime, again, we're very happy to set up kind of separate meetings just to talk through the specific bits of work that we're doing and how that might relate to sort of individual areas of research.
Great. And in terms of other hard to reach sectors, which are those that should be paying most attention to what you're doing?
I mean, probably it's the foundation industries that have probably this work is most relevant to. So that includes people like steel, ceramics, cement, maybe chemical sector. So we are already in discussion with those. So in fact, actually, the combustion test bed that we're building is actually we're renting some space belonging to Liberty Steel. So we're in close dialogue with them to work out how some of the things we're learning about these alternative fuels might be relevant to their operations as well. And again, we're in conversations with people from the cement sector as well. So yeah, I think those sectors certainly be happy to kind of have dialogue with.
Great. Well, I'm sure others will come through to you, and I certainly will. So thank you very much, Rob.
Thank you.
That ends our formal programme. I hope everybody has taken a lot from today. I've learned a lot, particularly about the huge level of activity and diversity of work that is going on in this area. The whole hydrogen debate has been transformed in the past 6, 12, 18 months. And as I think Angie Needle said earlier on, it really is a race, but it's a race that has to be run because it just is not viable to electrify everything. And hydrogen has such versatility. So thank you for your attention. There have been some questions. I think many of them were covered by our excellent presenters. I know materials will be circulated after the event. I guess all I am left to do now is to just put down a marker for tomorrow's webinar, which is on transport and hydrogen. We've heard a lot about industrial use, a lot about repurposing, a lot about different colours of hydrogen. But tomorrow there will be a full programme focusing on the scope for application in larger transport forms, freight, railways, shipping, and the like. And if you are interested to know a little bit more about what we're doing here out in Norfolk and Suffolk, do take a look at www.hydrogeneast.uk. And I should finally say thank you very much for Foresight Hydrogen for organising this really interesting programme, very topical, very timely, and hopefully this is the start of a conversation and not the end. So thank you very much for listening and enjoy the rest of your day. Thank you very much.